think we're just waiting for top of the hour so we have everybody, but we can probably start rolling here.
Well, let me just introduce myself very quickly. I'm Dan Keys. I'm the ESIP staff. I'll be just hosting this meeting, which means I just get the Zoom meeting running and make sure the recording is going. Here to answer any questions or put out any fires if we have them. We have a couple of other support people here too, those who've already introduced themselves. So I'm going to click on recording right now in Zoom, and we're already running live to YouTube. So take it away.
Great. Thanks so much, Dan. Thank you all for joining us for this remote ESIP session. I really appreciate you being here. We're here to talk about structured data on the web, putting best practice to work. This is a cross-program committee session that involves Information Technology and Interoperability Committee, the Data Stewardship Committee, and Semantic Technologies. And so we have representatives from those committees as organizers, as well as from associated clusters. And so the various individuals that have been involved in putting this together will kind of introduce themselves as we go through some of the lightning talks. They're all going to be giving lightning talks shortly. Just a couple of logistics before we get started. I believe many of you are very familiar with Zoom. As you know, Zoom is integrated. I think you found that button because you're all here. A couple of things. It's great if you can keep yourself on mute. We are inviting discussion. And so, obviously when that time comes, unmute yourself and then go back to mute. We're all in our home lives right now with kids, dogs, gardeners, whatever else is happening in our home environment that can cause background noise. So if you can be fast on that mute and unmute button, that would be fantastic and most appreciated. I'm not sure how the bandwidth is going to hold up, but it's nice to see everyone's faces on video. Again, no obligation to do so because we understand that you're in your home environments. But in particular, when you're speaking, it'd be really wonderful if you could share your video and say hi, and that would be appreciated. One other component to be able to easily kind of communicate with each other. If you're so inclined, you can rename yourself. Some people have, I just did this, I had my username as my name, but then I switched it to my actual name. So it makes it easier to identify and chat with each other. In terms of Kiko chat, this is what I'm sharing on the screen right now. Our agenda is structured so that you have a link to the notes, which you're already in, and a link to the slides when we get into that part of the session. The slides can also be reached at this point right here. So you can click on there to get to the slides. And Dave will be screen sharing. The chat that is down here is across the whole of the summer meeting chat. So if you're wanting to chat with all of us, then it's better to use the Zoom chat right now because that's just within the session. I also want to highlight that the agenda for today, session 1, if you click to the notes, it will take you down to where we will be creating notes. And so we welcome and invite everybody to participate in the note creation. It makes it much more representative of the conversation because I can be a little bit slow in typing. And we're also asking people to pop their names in as an attendee. I started doing that, but people started coming in fast and furious. So if you're able to pop your name in, that would be great. And so that we can all get to know each other a little bit, we do not have time to go around the room and do introductions. And so I also invite you within the Zoom chat, not within the Kiko notes, to just say hi, say what your interests are, which organization you're representing. That would be wonderful. Again, no obligation. So before we move into the session proper, I just want to check if anyone has any questions. Otherwise, I will pass it over to Dave. Okay, great.
There we go. Now you can hear me. Let's share a desktop and find some slides. All right, if you saw in the chat, my name's Dave Blodgett. I'm with the U.S. Geological Survey. Trained as a civil engineer, water resources engineering, developed a horrible data habit in college. 10 years later, here I am with helping to chair a session on structured data on the web. I'm sure we all have similar stories of getting carried away with information and data in our domain sciences or engineering, and have landed here. And so you all should see the opening slide now.
Yes, we can see it.
Great. All right, so I want to start with a little bit of interaction. So I'm going to bring, oh, you can't see that. I'm going to get out of slide sharing mode for 2 seconds. If you go to the top of your screen, and I just screenshotted this off of Amber's screen, but if you go toward the top of your screen, there should be a green thing that says you are viewing Dave Blodgett's screen. You should be able to pull down the view options and click annotate. So I would like everybody to do that now. I'm going to go back into present mode. And I'm curious, just to get a sense for the room and where everybody's at. If you want to type your name, feel free to do that. If you want to doodle, feel free to do that. Do whatever you like. But let everybody know where you are on this spectrum between technical, writing software, creating solutions for other people to use, and applied, pure domain science, just using other people's data, maybe just getting started in your career, that kind of thing. So this is fantastic. It's exactly what I was hoping for. It is awesome to have such a great group show up. Thank you, everybody, for coming along. So we have a proper scatter here. This is great. This is interesting. Few self-deprecating souls down there near the origin. Handful of very confident, technical, applied, par excellence folks. I noticed Ted Haberman disappeared. Hopefully he comes back somewhere. Okay, so this is great. I think your annotations should stay. Yeah, so Ted. So our goal with this session is just to help everybody get out somewhere a little further toward technical and applied. There is no need for the technical solutions without the applications, and to a certain extent, well, to a great extent, we cannot achieve our applications without good technology. And so we've got to be constantly striving to kind of combine both of these toward the best outcomes that we can. Now I'm going to have to figure out how to get this off the screen, because that's no good. Is that something I have to do? No, that's I can clear. So I'm going to screenshot this before I clear, though, because this is great.
I got it already, Dave.
Perfect. All right. So now we're going to clear that. All right. So thank you for that. Now I'm trying to annotate. So here's the plan for this opening session. We have a really nice series of presenters from a pretty diverse set of backgrounds and kind of projects that represent some work going on in the community, and I think kind of the status quo in our kind of structured data landscape. And those are really going to be, I think, definitional for us in terms of where are we at in the community, both in terms of problems in the applied space and solutions in the technical space. And so we're going to have this kind of track from lightning talks. Then we'll have 2 breakouts, and those are tomorrow, and we're going to do some legwork to get those breakouts set up in a way that's going to be most productive for everybody overnight. The first set of breakouts, we're going to encourage, they're totally free form. Folks that go to them can do really whatever they like. But we're basically encouraging folks to bring problems to the table, applications that are of especially high value and seem achievable, given a little bit of additional kind of technical solutions. And then the second breakouts, let's dig into some solutions and talk about what we can really get done as a community. So that's the kind of big picture plan. So let's look, I want to look at these lightning talks as first, and this is kind of the same premise as the two breakouts. First, what are the problems that you're solving with structured data? And or what kinds of things do you think you can do with structured data that would be that would kind of make what you're doing better, right? So those kinds of problem-based pitches or problem-based ideas for breakouts are very much fair game, and I think probably the place we most want to start. And so from there, we want to try to start thinking about how to understand the problem that we're solving. So, what are the issues around managing the actual data you're working with? What are some of the valuable outcomes that we could pursue as a group? Are there some social engineering issues that we need to take on? Are there some things in terms of motivations of people involved, or calling people out for not pulling their weight and not publishing or not doing the things that they could be doing that would make everybody else's life a lot easier? What are those details? Let's really understand this problem at a basic level, and then we switch to, okay, so how do we solve some of those problems? Are there best practices out there that people aren't aware of or are emerging that we could start to build some solutions around? Are there incremental opportunities in front of us that are kind of little things that would actually open up big potential in the future? Where are people doing a good job that we can start to copy success? Building on success is the #1 way that I've ever achieved anything, is really just copying what other people did successfully. So I'm just kind of illustrating some ideas for where we might take all this stuff. I really want to turn this over to you all to kind of take it for where you will. Hopefully that kind of seeds a little bit of thinking and kind of sets a tone. I have a lightning talk to talk about later that's going to be a little more topical, but we have a series of lightning talks here, a series of presentations. This slide is just kind of, this was actually just us organizing the talks and the speakers, and this is actually out of order, but it gives you an idea of where we're going. So we have some that are some topics that are more focused on data repositories or collections of structured data, and then a set that are focused a little bit more around best practices and technologies. So let's let those kind of organically turn into breakouts. We're going to go through these lightning talks, and then we're going to step back and have a kind of open conversation about where we want to take our breakouts. There are definitely some ideas on the agenda page in Kigo Chat and in Google Docs for what breakouts might be. But from here on, I think the slate is clean, and we can take those suggestions and run with them, or we can kind of rehash and think about another direction that we might want to go. So that's what I have. Before we jump into additional folks, are there questions, other things people want to bring up? Am I forgetting anything, missing anything? Okay. So we'll clear this annotation, and first up is Doug Fills. So for each of our speakers, if you could just briefly introduce yourself and tell me when to switch to your next slide. If you want to share your screen, I'm happy to pass it that way, but I'll also just run the slides kind of by default. So
nope, I'm good having you run them, Dave. So.
Great.
So hello, everyone. Thanks for the opportunity to talk here. I've got two topics I'll talk on up front here. And this is the first one, and I only have one slide. So my name is Doug Fills. I work for the Consortium for Ocean Leadership out of Washington, D.C. But I live and work actually out of my home in Iowa in the Midwest. And I'm also part of the IGSN 2040 technical committee or technical group, whatever it is we call ourselves. So, and this slide is really kind of to introduce some work that's taking place inside the IGSN 2040 community on the evolution of how the IGSN deals with placing physical sample information on the net. So currently, it's an XML schema. It's published by the physical sample community using OAI PMH, and that's the current involvement. And I should really probably mention a little bit what the IGSN, right? So the IGSN is a identifier for physical samples. So in the same way that we have ORCIDs for people, we have DOIs for publications or data sets, the IGSN is an identifier for physical samples. And we really want that identifier also to be part of an emerging ecosystem of these types of graphs that are appearing. And that's probably a good segue term in that, because one of the things that the IGSN is now looking at and now exploring is leveraging structured data on the web as a mechanism for publishing the information about these physical samples, and also for harvesting and building indexes out of what is published on that information. And there are many reasons, I think, why we're kind of looking in that direction. And there are probably similar things that you've heard people talking about structured data on the web already. That is that you can leverage a lot of the developer capacity, especially when you're looking at things like JSON LD. You have all the JSON tooling that's at your disposal. You have the ability to easily incorporate in the vocabularies and the context of those environments. And you have the web architecture at your disposal too, both for the publication and for the harvesting of that information. And so we did some experiments. We actually did a sprint a month or two ago. Down in the lower right corner, you can see Marum, Potsdam, Cairo, and Cesar all published information about physical samples using JSON LD. We then harvested that with Gleaner, which was a package developed during the EarthCube work, and then placed those graphs and some of that information online at samples.earth and experimented with how we would build interfaces and do queries into that environment. And so this really, I think, is just an example of a new community, right, outside of the dataset community, exploring the structured data on the web pattern, trying to learn and leverage some of the experiences that we already have that we can bring to bear on that, and applying it then to this new community. And I think one of the interesting things too is that some of the people were looking at then how would you integrate this with things like the Freya project and stuff like that in Europe. And I think that's one of the really interesting, powerful things that we can do with this, is that a lot of these capabilities are of the web. We can begin to look at the emerging work taking place inside some of the convergence accelerators and things like that with open knowledge graphs, and how we can integrate these things together through systems like that. So that's just a brief introduction to physical samples on the web leveraging structured data. So Dave, I think we can probably move on to the next set of slides. Okay, so now for something completely different. So this is a software package that I've been working on, and it's come out of lessons that Adam and I learned in Project 418 and Project 419, discussions that I've had with him, and interactions that I've had with some other groups online as well, Mike and some of the other people here. And really what this was I was very interested, as we're looking at structured data on the web, to begin to have an environment in which I could play around with some of these multiple patterns that exist. And those patterns that were of particular interest to me were things like the Research Data Alliance Digital Object Cloud pattern. That's the little diagram in the lower right there, where you have a digital object, and then that digital object has another digital object that is its metadata information that's associated with it. And that's kind of like the core kernel of that approach. Some of the other things that I was interested in were the digital object internet protocol from Donna. And this was some work that's taking place on an actual internet protocol in terms of dealing with digital objects. And not that we've implemented that, but it's very inspirational, I think, in some of the approaches that we're taking to these. Of course, we were looking at things like structured data on the web and the approaches that we do there, and then also the web architecture environment. And so when we take all these principles, I really was interested in what a software package would look like that allowed us to play in all those environments simultaneously. And so I created this package called Grow. It's available on GitHub, and you can find more information about it there. And I'm running several websites online with it now. And at its very simplest, you could probably think of it as like a CMS for digital objects. Now, there are many headless CMS type packages that you get far more capable than Grow. But I think some of the things that are kind of unique about Grow is this ability to apply some of these core principles that are of interest to this community into one location. And so in many ways, Grow becomes an environment to experiment with these in. Dave, if you could just pop me off to the next slide here. So this is the last slide that I have. So one of the things that's particularly interesting to me in exploring structured data on the web is how we can actually begin to leverage some of the vocabularies that would allow us to connect object with services, for example, to be able to say that I have an object and I want to transform that object to a new representation. And in some cases, I may have pre-computed that representation and made it available inside my object store, in which case you could just simply content negotiate for that and obtain it. But in other cases, those representations may be things that can be reconciled through a service call. And so then the question becomes, how can we describe that service in such a way that we can couple that service to that digital object, such that a package like Grow or any of the others could then turn around and expose that as a capability to someone inquiring about the various range of capabilities that are available on that digital object. So this is a software package. We've been playing around with it. If people are interested in this, I would love to get you involved. If you're interested in doing some software development in Go, I would love to walk you through it and get you involved in it there. And just as a conclusion then, the image to the right is kind of represents Grow's position in a full stack implementation. So I'm re-implementing the Geodex site that was developed during EarthCube. And so it's available at alpha.geodex.org. And this is Grow's position in that stack, right? And so you can see Grow talks to an object store. And one of the nice things is that we're working on Gleaner then obtaining the digital objects, the JSON LD objects from crawls and generating graphs and throwing into the back end on that. And so you kind of have this kind of continuous object chain developing where people can publish information, they can harvest it, test it for interfaces, and then iterate quickly on it. And I think that's one of the things that I really want to be able to do here is iterate quickly on concepts inside here on these different areas and explore some of these opportunities. So if you're interested in that, let me know. And Dave, that actually concludes both my presentations.
Perfect, thank you, fantastic. And now I have annotate turned on. I'm going to clear everybody's annotations. Thanks for the loving of particular parts of the talk. And next up is Mike Johnson. Take it away.
All right, thanks, Dave. So I'm Mike. I'm a grad student at UC Santa Barbara. So kind of the title here is Can Slightly Improve Data? Is it plus or minus better information? And this is ideas coming from talking with Adam and Doug and Dave over the last year, working a little bit on the GeoConnects project, but mostly with the Urban Flooding Open Knowledge Network, which is part of an NSF funded project. So if you would mind, next slide. So today I think there's two challenges that I'd like to discuss, and I'm very new to the structured data stuff coming from a GIS background. The challenges that we've had with the Urban Flooding project is what do we do with intra and intra data set collections, and how do we traverse different domains in a structured way to get improved information. And so those are the two I'd like to talk about over the next few slides. That should be good on that slide. Yeah, so the first first challenge is what happens when we have the same feature represented in multiple different collections. So this is an example of a dam. It's represented by the FEMA National Flood Hazard Layers. It's represented by the Army Corps National Dam Index. It's represented open street maps, both as nodes and ways. It's represented by the USGS and the Guinness, and it can be represented as intersections between like water bodies and flow lines. So we can align all these different things by spatial proximity, network topologies, natural language matching. But the idea is that we ultimately have unique attribute sets that come from each different data set. And sometimes they are additive, so sometimes they give us additional information, but other times they're contradictory. And the example here is that often the location that we get is very contradictory. So how do we define the best location from a set while also keeping the added information that we get? And as you can see, the names there similar, but different enough that what's the right name? What's the right location? How do we define these things from collections? And then the converse of this on the next slide, what happens when we have, or sorry, one thing about this is each one of those comes with these different attribute information that could be stored with them, and all of them are web accessible in their own right. So how do we store the resources? Do we actually store the data as part of a feature, or do we store the links to data that exists elsewhere? And so then on the flip side of that, we have the intra-data set connections. And so what happens when within the same feature or within the same data set, you have many features that act as a collection? So here, and the title should be intra-data set collections, but here, this is a system of dams that work to control water in this area. And so each of these features has different attributes, but the same common identifier within the National Dam Inventory. So how do we collect this and treat both the collection of dams as an individual object, but also the individual dams themselves, which have things like crest heights and widths and depths and typical flows as individual objects itself? So what is the main thing that we want to deal with? Is it the collection of dams, or is it each individual feature of this dam collection? And so how do we deal with this network or collection is something that I've been struggling with some, and would be great to get some ideas from this group. And then on the next slide, I think going into the second challenge, or the main questions, I guess, that come from that is how do we document these collections? Whether they represent the same world feature, but they represent it differently, or are they part of a larger aggregate system? So the result is, even if you have a larger aggregate system of say 15 dams and they have 6 different representations each in different data sets, all of a sudden you've got 6 times 19 different dams. And how do you determine what is the right information to feed different systems that might want to use this? And so then on to the second challenge of traversing domain data is we might have something like these urban spatial features, which could be buildings, roads, dams, bridges, anything that you might have. You might have hydrography data sets such as the NHD, the watershed boundary data set, anything that represents hydrography. And you might have hydrology or hydraulics information, which might give you stream flow at these particular outlets. So the question that we were interested in this project is how can we forecast flood information that's relevant at the feature level in urban systems, traversing these different data sets that use common identifiers such as the NHD catchment, but aren't structured in a way that can directly get meaningful information out of them. And so on the next slide, we kind of decided that the structure of these data sets is both in the identifier of the data sets we're interested in, but the structure then is really also in the geography. And the geography is both an object and a field type of operation, that you need XY locations for many things, but you also need elevations, which is field or topography type of information. You can also have maybe field land cover, field population values, people census data. So how do you take these different geography representations, align it with the IDs of what you're interested in, and then make some sort of structure that you can get information in? And the takeaway here really is, let's say you have a house that you want to know if it's going to flood, but you have 4 different representations of that house that have 4 different elevations and 4 different XYs, and you have one hydrologic model that's forecasting. How do you bring all of this together in a structured way? And so then on the next slide is our solution for this was that we really wanted to know what an object was. And that is really the entity itself. So that's the dam or the house or the bridge or the road. But we also need an understanding of where, both in terms of indexing, where is this object in terms of a hydrologic sense, and where is this object in terms of geographic space. And so we're breaking this down into ideas of indexing and addressing. But then the challenge becomes, okay, we have these features that exist in many different data sets. We're assigning indexes and hydrologic space. We're assigning locations and geographic space. And ultimately, how do we make sense of that information? So on the next slide, we get that the result of this is if somebody asks a question such as will my house flood, we get we have to answer the unique question, what is my house across different representations? Where is my house, both in hydrologic space and geographic space? What are the conditions of my house from environmental models? And what is the information that all of this together brings? And so the structure of these different existing information data sets, through slightly improving them by relating them, allows us to connect geospatial features to geospatial fields and objects to environmental models to provide information like what we see on the right, which are object-based flood maps or interactive frameworks that emergency first responders or people can look at to identify what features or what objects might be impacted given a certain hydrologic forecast. But then with this comes the challenge of scale, as with everything. And Dave, would you mind going to the next slide? That we have scale at a spatial resolution, we have scale in terms of data volume. And so when we built this out for the Houston area that you see on the left there, it's almost 2 million features. And this is only one representation of each feature. So this is neglecting that, dams are represented in different places. Buildings are represented both by OpenStreetMap and OpenAddress. Local agencies might have their own address points. So once we start scaling this kind of idea up to get operational flood forecast at the object level through a structured data, how do we deal with this problem that ultimately we're just going to blow up the size of what's there? And so that leads to the last questions that I'd like to maybe pose to the group on the next slide, is that how do we document these collections at scale while maintaining feature level URIs, so keeping the information that we know about each feature? How do we preserve and aggregate the attribute information about them such that they can be communicated in a meaningful way? How do we ultimately conform all this to a common schema? And while doing this, how do we actually make the system remain performant as we get larger and larger and larger? I think as the UFOKN moves forward and some of these other projects, these are going to be the challenges that we're really thinking about. And it'd be great to hear some feedback from this group. Then on the last slide is just the thanks to all the people involved with this, all but Keith, who's my advisor, is on the call here. Funding comes from that NSF project, which I mentioned. So that's what I've got. Thank you very much for taking the time.
Cool. Thanks, Mike. The your scale point blows my mind a little bit. All right, so I'm going to kind of follow on what Mike was talking about, but step back to kind of one level more abstract, I guess, and talk about this project we've had going on called the Environmental Linked Features Interoperability Experiment. And many of you are familiar with this. It's been going for 3-4 years now, actually. And we're finishing up the second experiment, and I'm just going to kind of dive in and give a very brief overview of the first one, where we landed with the second one, and the kind of what the next open questions are. So the first one came up with these two, what we referred to as views of a linked data graph, and it's a feature-centric linked data graph. So it's a spatial feature. So many of these are schema.org associations that basically just give you a simple, in this case, preview of a feature, right? And this would be, say you're publishing a stream gauge, it's a feature. What information should you be publishing in terms of structured data? So this work was pretty satisfying. It's fairly well contained, and we put something out that I think was pretty useful. We did two kind of primary views of a feature. One that's a preview. The other is this kind of idea of a network, or what is the feature related to. And this work was all done very consciously avoiding some of the harder questions around what do you do about kind of the network architecture to support all this stuff. So in the second Environmental Linked Features Interoperability Experiment, SELFIE, acronym I'm rather proud of carrying forward, but it wasn't my idea. We tackled this issue of documenting real world features with identifiers that can be resolved on the internet. And all of the spatial data on the web best practices and kind of the canon that we were able to access at the time was use indirect identifiers. So using your email address as an identifier for you. That was the way that everything was kind of said to be done. But we came up with some pretty good reasons to really pursue this 303 redirect. If you're familiar with the range 14 decision, this idea of how do you have a URI that's an identifier for a real world thing? Well, you do it, and then 303 redirect see other to a digital object that that has information about that real world thing. So we took that on, and I think we came to some pretty good conclusions about how to handle landing content. We hesitate to say landing resource or page, but landing content that would be available from some resource that's the target of a 303 redirect. But we still have a lot of open questions around this distinction between landing content and data. And that's because metadata is in the eye of the beholder. It very quickly becomes data, depending who you are and what your use is. So we kind of have this spectrum of super complete to super simple for 4 functions. So identification of a feature, this idea of a landing page, the default content that you would want to give you a preview of a feature, structured data, just kind of the linked data view, the network view, and then data, actual representations of that feature. There are a few different profiles that you can implement of that, or a few different levels of complexity, if you will, that you can implement. And these are presented in our draft engineering report that was just finished up last week and is kind of going out for review right now. So open questions here, and I'm going to echo a little bit of what Mike had to say, but the thing that I think is really the hardest right now is how are we going to handle observations, and especially, so feature collections, and especially feature collections that have observations available for them. There have been a lot of solutions to observation collections over the years. None of them have really gotten legs in terms of creating catalogs of observational data that are really kind of well-curated community capabilities that allow you to search and then gain access to actual observation data. So that's the kind of top level. Second one we really ran into problems with is this idea of a resource that can provide variable content, right? So you've got media type negotiation. You might have multiple schemas of the data available. There might be multiple profiles of that schema. Language is a super common one. Multilingual support becomes a big deal as soon as you step outside the US borders, et cetera, right? There's a whole list of ways that we want to vary the content we get back from a given resource and document what happens to be available from a particular resource. And there are clear paths to try that, but there's a lot we need to explore there, especially for how we document that world of things that are available for a certain resource. And then the last one is really meta, but a landing page is kind of a hard thing to nail down because you don't want it to be a thing since it's about the real thing. So and this is the issue of, a DOI is a DOI, but the publisher's landing page for the DOI is the thing that Google indexes. And how do you get around this issue of, well, I don't want you to index the landing page, but I want everybody to go there. And I don't want to have a reference to the landing page, but I want to be able to tell you what its type is. And there's some really tricky kind of meta questions around this issue of the default thing being the thing you don't want to talk about for various reasons. So those are my 3 kind of top level questions or open topics to discuss and tackle. They all need to be focused before we can talk about them in earnest, but that's kind of where my open question list is. So that's my section, and I believe this is Adam.
Is that okay? Oops, I just lost it. Hold on. Can you guys hear me?
Yeah, Adam, we can hear you.
Okay,
yeah,
great.
sorry, I was muted. Yeah, we can hear you.
Okay, great. Thanks so much for coming to this session today. I just wanted to take a couple minutes to talk about the schema.org cluster here at ESIP, and originated out of an effort coming from NSF EarthCube space that was really trying to look at modern techniques in web publishing for describing web pages and sort of marrying that with what was happening in science with metadata descriptions about data sets and other research resources. And so sort of marrying these two so that data on the web coming out of science can be easily discovered and well described for folks to find those as the corpus of web pages on the web. Yeah, just sort of explodes here. So that was the effort. And so this group at ESIP revolves around tackling how to inform data repositories and data publishers on the web to use this technology of schema.org. So we can go to the next slide. And so what came out of that EarthCube project was a set of guidelines that's kind of walked through how to describe a data repository and data sets in your HTML markup. And so I kind of envision ourselves as like Steve Irwin's kind of guiding folks through the jungle of web markup and structured data and sometimes RDF. And so essentially this cluster is developing these guidelines, and you can find these at scienceonschema.org, which redirects right to our GitHub repository with those guidelines in it. We meet on the first Monday and fourth Thursday of every month. We have a living agenda in a Google Doc that'll sort of walk you through all the discussions that we've had. And our primary goal is really just to sort of educate the community through workshops and activities like the summer meeting here on what we're up to and what the current state of these guidelines. So we can go to the next slide. And so you might ask, if you're familiar with schema.org at all, like, why do we need extra guidelines? I mean, clearly the schema.org website has instructions on how to publish. But if you've tried to look at schema.org, it's really flat descriptions of all these interconnected, rich relationships between data and the authors and the organizations that came out of it, maybe the research projects that funded this data, what variables were measured, what instruments were used, all sorts of really good information about these data sets. And so it's really hard to get a concept of how to publish out this graph of data with these flat descriptions and really understand how things are connected by looking at the schema.org pages. Also, there's limited examples on the schema.org documentation. And so this effort coming out of EarthCube wanted to provide, better examples and better drawings of how things are connected so that folks can just understand easier what schema.org is trying to do and what's possible there. And so the question became, for the genesis of this ESIP cluster, was how do we share patterns of use so that no one's sort of left behind with trying to figure it out and start from scratch how to describe data sets on the web. Next slide. And so these drawings and examples that are in the scienceonschema.org GitHub repository kind of look like this. We try to give very detailed descriptions and detailed examples that sort of build on each other. So you can sort of, as you read down the page, you're sort of building on the fly a description using schema.org. Next slide. And so, we're not just a group that meets and chats and has high thoughts. We try to put those thoughts and capture them and put them into action. And no joke, on April 1st, we released our most recent revision to those guidelines. And we had 7 folks contribute to those guidelines, which is fantastic. Every single one of those people wrote and made modifications in the descriptions and created new examples and drawings. And we've DOI'd this collection so that folks can understand, which versions are which when they come to the repository. We've also adopted some release notes here that sort of walk you through as we make changes to this guidance, sort of what was fixed, what was improvements, and then new features. And so I just wanted to highlight a couple from this version 1.1. So if we can move to the next slide. One of the changes that we made in 1.1 was to document sort of like our release workflow. And this was great because it sort of lays out how to contribute as someone new that's coming into this group. Certainly, not everyone can make the telecons for the in-person discussions, but we wanted to make it clear how to jump into GitHub and contribute right away. And so we published a workflow on how we move from releases. And if we can move to the next slide, another sort of iteration or improvement that we made in the group was to adopt what are called architectural decision records. And so certainly there's a lot of discussion that happens during the telecons and in GitHub, and sometimes very sticky issues have very lengthy descriptions. And so to help boil down for someone that's coming in fresh to an idea or a concept, these architectural decision records sort of boil down all the essential information about a particular decision that we've made in terms of the guidance that we're providing on scienceonschema.org. And so these ADRs help you quickly understand an idea, the decisions that were made around it, and the consequences behind those decisions with links into the GitHub issue queue for more context. And then just two examples of changes that we made in version 1.1, if we can move to the next slide, is we improved how we describe identifiers for data sets and organizations. And that was using this technique in schema.org called a property value. And so we've got a description of how to cite a DOI, an ARC, a PubMed, PaleoDB, a whole bunch of identifiers there, ORCIDs for people. So another sort of change and update in 1.1 was guidance on dataset licenses on the next slide. And thanks to, and this is the great thing about ESIP and having so many people connected, is that everyone's ideas are accepted and interesting. And so this was a great idea to use SPDX and the work that they had already done on describing licenses for the web. And so using SPDX, we were able to publish out guidance on how to cite dataset licenses, which is fantastic. And if we move to the next slide. So yeah, as part of this week, we're going to continue working on our next release, which is 1.2. You can check it out in the milestones section on GitHub there. Look for 1.2. We're covering all sorts of topics. So describing dataset variables, provenance between data sets, validation using Shackle of the schema.org that you publish. And this week, if you come to the schema.org session tomorrow, you'll see a tool that's been released for Chrome that'll let you look at the schema.org on a particular page and get a report on how well it fits or how well it meets the guidelines for science on schema.org, which is fantastic. That's some work done by Dave Yeaglis and Doug Fils here. So yeah, come check us out tomorrow, 4 p.m. at the Advancing Schema.org guidelines for dataset interoperability and discovery. And then again, we meet on the first Monday and fourth Thursday of the month. And so we're looking forward to participating today and tomorrow in these structured data sessions. Thanks.
Cool.
So I think I'm up.
Yep.
Okay. So as you just heard, there's a cluster in ESIP that is trying to develop guidelines for the earth science community.
Wait, Ruth.
Yes?
Can you introduce yourself?
Oh, sorry. I'm Ruth Doer with the Ronan Institute for Independent Scholarship and a long-time ESIP member. Probably almost all 22 years. Well, anyway, I've been involved with ESIP for a very, very long time. So as you know, there's this schema.org cluster that was just talked about that's trying to develop guidelines for how to implement schema.org in the earth science community. Part of the reason for doing that is to improve data interoperability. But it is also true that, as you saw with some of the images, there's lots of how to do any particular thing, like do an identifier, for example. You saw on the diagram that he showed that there's, 4 or 5 different ways to do an identifier, even if you're using a common style of identifier. And in many cases, there may be groups that want to further specify exactly how people implement schema.org to make integration of systems easier. And so the question I'm asking the community, and hopefully we'll be talking about at the 3rd of these sessions tomorrow, is should they proceed in doing that? And if so, how should they proceed? And I have an example I'd like to talk about a little bit to show you what the issues really are. Okay, I'll start my video. Fine. So this is an example that has come out of the Polar community, which has for decades now wanted to be able to do sort of a single search to find all of the relevant data across all the holdings of all the repositories in the entire world that have that kind of data. And you'd think it would be a very simple thing. I mean, all they're talking about is they want to be able to do a time, space, and parameter-based query, which is something you'd think was solved, maybe years ago. All right, thank you. Wasn't quite ready, but that's okay. Leave it.
Sorry about that. I was being pinged for next slide, so go ahead. Tell me when to switch.
Okay. And so that community is the Polar data community. And so now is when I was expecting the next slide. Thank you. Sorry. And this is a community that some of us on this call, for example, Mark Parsons, and I have been involved with for decades. And it's a community that has been trying for those decades to actually get, a uniform query across all of that data. The problem is that, as you might expect, that data comes in all shapes and sizes. It's stored at, currently the list is about 81 different repositories scattered hither and yon around the world. And they vary in their technical capacity greatly, from large organizations with lots of people, for example, NCEI, from NOAA, to organizations with maybe 0.1 FTE of a data manager and 0 technical people. So it's been an issue. And that group has been meeting regularly in the recent years. You see on the right here, I don't know if you can see my mouse, but just in the last couple of years, there have been 3 meetings. And this Polar to Global Online Interoperability and Data Sharing Workshop and Hackathon is a new series starting up where every other month that group will meet to try and make this actually happen. And so now next slide. So this is the issue. The problems are, a lot of them are social. Standard metadata isn't standard. In other words, if you're trying to bring together all the ISO metadata records in the world, you're going to find that everybody implemented it differently, so that you'll have to actually hand tailor your software to deal with each of them. And in the Polar case, there are literally 81 repositories. I'll show you a map in a second. And they're being aggregated, and they're being aggregated by aggregators who are aggregating other places that have aggregators that are aggregating other places. So actually you end up with huge cycles. And there's many technologies in use. This is a very partial landscape map from that meeting from the previous slide in 2018, where people were trying to figure out who was doing what and making their data available how. And next slide. And so this is a graph of who's harvesting what from whom. And you might want to notice that, yes, there are some big centers in there like NCEI and GEOS and GCMD and the Polar Data Center and NSIDC and Met Norway and Data One. And there are a lot of circles. So what you end up with is metadata harvested from point A that came from point B that was harvested from point C, and it gets very cyclical. And in many cases, people end up doing things like assigning new identifiers to them for their own system. And so just figuring out what data is really what and where becomes a nightmare, which is why people were trying to go with something like schema.org, which would be, quote, simple, and is something that even the 0.1 FTE style repositories could implement, such that if we could at least get a common representation of time and space and parameter, the Polar community might actually be able to implement its goal from 20 or 30 years ago. So next slide. So this is really a pitch for session 3 on Wednesday. And it's, so if people really want to do this, which they really do, there's actually a group, the Polar group. It's under the auspices of the International Arctic Data Committee that is actually trying to get data from all 81 of these data centers into a common search interface. And so if you're interested in helping answer these questions, please come to that third session. Next slide. And the real question is, are we all willing to care a little bit about data that doesn't look like ours as we build tools? That's the real question, because what this requires is for all 81 of those repositories that range in size from, NCEI all the way to 0.1 FTE. To do at least a few things in enough of a standard way that you could actually do this sort of thing. And in many cases, you'd say, well, hasn't Google solved this problem? But if you look at Google's dataset search and you look at some of the data sets in there, like some of the data sets from NSIDC, which seem to come from, you'll find out that they have many records that disagree with each other. So that's my, that's what I'm trying to get to happen here.
All right, it's good. It's a great illustration of same problem, different data center, different area of the world. So next up is Gary.
Thank you, Dave. Can you hear me okay?
Yep.
Okay, good. Good afternoon, everybody, or morning, depending on where you're from. So I'm Giri Prakash. I'm from Oak Ridge National Laboratory. I manage a data center here, which I'm going to talk about it in the next few minutes. I have also invited one of my colleagues, Ranjit Devargonda. He's our system architect, and he helped me with setting up the data one member node and so on. Next, please. Okay, so what is ARM? ARM is an atmospheric radiation measurement. It's a Department of Energy's national user facility, and it's a huge observational network. And we have been collecting Earth's atmospheric data to study the cloud life cycle, aerosol life cycle, and how it affects the overall precipitation budget. So if you look at the map, we have been collecting lots of atmospheric parameters from Oklahoma, Alaska, and then there is a tiny Portugal island in Azores. And all the red dots that you see, those are all the mobile facilities where we ship containers full of instruments and then go study a specific climate phenomena. Next one, please. So as you have seen, we have gone to different places, and we really pushed ourselves in terms of collecting atmospheric parameters from all the way from Arctic, where we have 2 sites, one in Barrow, Alaska, the other one is in Licktock, further north. Then we also went to, back in 2017-18, we went to Antarctic. Fort McMurdo Station, as well as we actually used a true mobile platform where we hired a cargo ship that went back and forth between Tasmania and Fort McMurdo Station in Antarctica, rough southern seas. So we were able to collect quite a few cloud related parameters. Next one, please. So our recent effort is part of the international program, which is the Arctic expedition, and the big ship, Mosaic ship, which is frozen on the Arctic, which is getting drifted. And we have over 50 instruments continuously collecting data, hundreds of terabytes of data from over 50 instruments. So that's what we have been doing recently, along with all the other mobile facilities, as well as our long-term experimental sites. Next, please. So that's the science side. So how do we manage the data? So we get over 2,000 continuous data streams. These are all sensor-based observational data coming from all these different sites and coming to Oak Ridge National Lab, where the ARM data center is located. And we actually have quite a few complex workflow that ingests the data, creates data quality information, and then creates higher level value added products, all through automated process. And we have a robust metadata team that continuously keep up with improving the quality of the metadata. And the data gets archived and distributed to the user community, as well as made it available through the HPC system. And so right now we have over 2.1 petabyte of data from 11,000 data products. Most of them are collected by the ARM facility. And we have, most of the data are in climate, climate science data format, which is the NetCDF data format. Next one, please. Okay, so obviously we have a good data discovery portal, which allows all of our community to come and discover our data. But then we also provide our metadata through various data gateways. You can actually see both ends, like from DataGov to DataSite, the NG Arctic. On the right side, you see the Data One portal, which is what I'm going to talk a little bit about it. So we were able to achieve all this by providing different types of metadata, standards-based metadata records, and let the gateways harvest it. And the way we are doing it, it also, like as I mentioned, these are data are continuous data streams, and it arrives all the time. It's getting collected from every seconds to every few minutes. So allowing the clearinghouse to harvest our metadata and make it discoverable in broader portal, not only like allows us for greater visibility, but from the user community perspective, the user can look at our or find our data, but then to download the data, they come to us directly, so that they can get the latest and greatest data, not only the data, but also the data quality information and additional details about the data. So, next one, please. Okay, so coming to data one, so why I'm interested in data one. I've been involved in data one from from long back, and would like to see the data that I host here at Oak Ridge gets greater visibility through the Data One portal. But also there are a few other specific scopes that I would like to achieve it. One of them is, as I mentioned, the Mosaic expedition, where over 20 countries actually doing research on that ship and distributing the data that we collect to broader community rather than sending the data to Mosaic central office. We actually came up with an idea to publish it through the data one, so that as a member node, ARM is started publishing the data through data one, and whereas the Mosaic's primary data source, Pangaea, is also part of member node. So I thought, like, okay, this is a great idea. So we can actually share our data by using data one as a broker service, if you want to think that way. So we started with initially we started with taking the North Slope of Alaska measurements and data, and we had some challenges, primarily because of our continuous observational data stream nature. But we were able to figure out, with the help of Matt, Dave, and many engineers within Data One and also from ARM. So we were able to publish our metadata, but then we recently released our metadata from the Mosaic expedition itself, and I'm hoping the Data One would be soon make those data available through the Data One portal. Next one, please. Okay, so Matt and Amber requested me to talk about our experience in publishing our data through Data One, and obviously with this volume and diversity of our data collection, it is very difficult for us to actually ship the data to Data One. Instead, we use their latest model of publishing the metadata. It's a lighter member node, if you want to call that way. So we used that, and we used the JSON-LD, schema.org structure, as well as we provided ISO 19195 metadata records. So I will let Ranjit, my colleague, to talk about some specific challenges that we faced and also the opportunities that we had. Oh, can you please stay in there? Thank you. Go ahead,
thanks.
Ranjit.
Thanks, Giri. Hello, everyone. My name is Ranjit Devarakonda. I hope you all can hear me okay.
Yeah.
So I'm a senior software engineer at ORNL as well. I work with Giri there for the ARM data center. Like Giri said, overall experience that we had with Data One team was great. You know, with the amount of data that we have at the data center, there were a few challenges that I have listed there on the slide. I'll quickly, go through the points here. So like the first point is like on the slide 2, I think Giri presented a geographic footprint of ARM where we've been collecting data from several different locations around the world. So like these are all observational continuous data. So it's again like challenging for us to sync it at data center itself, and to have the data distributed to other gateways. That would be another challenge, to keep the sync in sync with other data centers. So that's one of the challenges we had. So we had some harvesting issues there. We are working with the Data One team to resolve those. Data One uses a really good schema validator. It's good. It's thorough. I think it was in this test phase, but I believe it's now moved on to the production server. But one of the challenges that we had is to confine all our metadata to that specific schema, if you would. We had to make up a few things along the way to get it into that standard. But again, like this is was not a clean way of doing things. Primarily because we have several instruments, same instruments located at several different sites. So for us to get everything unique for each metadata record was a bit of a challenge. Sorry, I didn't see the start videos. Okay. So the third point there is basically like some sort of a reporting, if we could get back from data one, like just to tell the data provider what were the harvesting issues, and also some sort of metrics like how our data and metadata are being used by other folks. More like a periodic reporting. That would be a good thing for the data providers. Well, I don't think I have anything else to add there, Giri. Do you want to add anything?
No, that's all. Thank you. The last point, Ranjit, is what I would like to reiterate. If there is a way for the data providers or the member nodes to get, recent status update from the harvesting effort, that would be great. Yeah. So, thank you.
All right, thank you. Next up is Kyle.
All right, thanks. Can everyone hear me?
Yeah, pretty well.
Hey, my name is Kyle Onda. I'm the data architect at this project called the Internet of Water, which is currently housed at Duke University. And I'll be talking about something I've been cooking up mostly with Dave over the past 4 months or so, which is called GeoConnects, which is a collection of community reference features. Next slide. So just to introduce everyone to what the Internet of Water is, this has been around as a concept, maybe with this name, for about 3 years, since an Aspen report dialogue series. And so it's sort of 3 things. It's an aspirational concept of a linked water data system composed of, that's links together water data users and producers and the hubs, which are sort of the aggregators of produced water data. It's kind of a decentralized effort with participation from many entities in the federal government, some state governments, academic, quasi-academic outfits like Kawazi. And then it's an actual organization, a branded organization, which is what I currently work for at Duke University, that's supposed to provide some social and technical infrastructure supporting that effort. And as an organization, we are kind of focused mostly on direct technical assistance to state and local agencies. A massive amount of Earth observation data is produced by state and local government agencies, but a lot of it is not really aggregated or published outside of those agency systems currently. Next slide. Right, so I think it just skipped, it's fine. So the use case is basically similar to what Ruth described. So a typical water data user probably searches online. I want to know some parameter about some lake, and maybe the top result is some USGS page with data. We want it to be, next slide. We want them to get the structured metadata about all of the data produced by all organizations from relevant environmental features to that lake. So the tributaries upstream and all the different kinds of parameters that are being monitored for by all kinds of different federal, state, local, academic, and NGO type organizations. So that's a tall order. Next slide. And this GeoConnects is taking a little bite out of it, maybe. Next slide. So I'll just describe what's sort of going on with this. So on the right, we have this idea that really piggybacks on what Dave presented with the Selfie project, that there's organizational landing content that points to some data. And what GeoConnects is mostly about is providing what we're calling community reference features. So these are common locations where a sensor might be deployed at, a feature of interest that sensor has data about, or cataloging features, so the common spatial kind of geographies that you might want to query a catalog of metadata for. The idea is we have common reference features. Next slide. And these features might have minimal topological links between them to make some sort of small knowledge graph. But really the power is, next slide, that organizations can then embed structured data that links to these community reference features, and that this can be a way to build kind of a more common knowledge graph. Next slide. So we've instantiated these community reference features for a lot of features already at this info.geoconnects.us OGC API stand-up. In this example, there's already an EPA page to say that references this this feature, which is a public water system. Next slide. And then we've also stood up a persistent identifier registry and a persistent identifier server, so that these reference features have HTTP range 14 URIs that 303 redirect to these landing pages. So it's sort of an operationalization of the selfie concepts that Dave talked about. And of course, next slide. And anyone can mint a persistent identifier. It's a GitHub-based registry, so you can sort of upload a CSV of all the environmental features you have data about, and mint PIDs for your pages as well. And the EPA has actually done that for one of their data products. So next slide. So there's a lot of next steps and outstanding issues though, advance. So who's going to steward all these reference features? Right now, it's literally Dave and me. So we need to develop communities or task existing organizations to do that kind of work. Next, how to make all this linked data actually useful. You know, we need to make some kind of sitemap of the PIDs that we can crawl, advance. You can advance like 3 times here. So we need some sort of crawler to do that can populate a data store and maybe serve that out as a catalog. Another big problem, again, echoing something Ruth talked about, is a lot of the organizations I care about don't publish data anywhere close to this way. We're talking about 30-year-old Informix databases serving out regulatory data. We need kind of easy, cheap ways to publish linked data from easily accessible formats, you know, from people who've never heard of schema.org or RDF. Next, advance one more. There might be some kind of in with getting participation from major, not just water, but environmental data management vendors to expose data in this way. Next slide. We also need to talk about we need to figure out kind of guidance for what to mint PIDs about and what kind of links to do, echoing a lot of what the schema.org cluster is talking about. Like what kind of links do you do? How do we handle kind of indirect links? Do we rely on everyone publishing data in this way and have a kind of a more brittle system? Next, and then finally, again, echoing Ruth, how do we deal with this? And Mike, how do we deal with duplicated and aggregated and kind of republished data? How do we represent those relationships? You know, having common reference features is one way to do that, but there can still be duplicated data that about the same feature, right? That'll do it for me. Tried to go fast.
Okay, folks. Lewis McGivney here, NASA JPL. Good afternoon. This session here that we're pitching is collaborator here is Carlos, Dr. Carlos Reda from in Barry, and Carlos is on the call as well. So just to say hello, Carlos. Next slide, folks. What we're going to be focusing on.
Hello, everybody.
Hi, Carlos. Thanks. Okay, so do you want to introduce yourself very quickly, Carlos?
Sure. I'm Carlos. I have been working as a software engineer at Embari for 10 years, 11 years now. And have been the main developer of the MMI ontology repository software. So my MMI is the Marine Metadata Interoperability Project that was around for a few years, funded by NSF. As part of that effort, we make connection with ISIP, of course, and the connection has been in place for several years. And more recently, this software was adopted by ISIP, which is great. It's part of the plan to make it more visible out in the community. And I'm here just to try to help to facilitate that process.
Thanks, Carlos. David, how long have we got here for this? We're going to rattle through this stuff pretty quickly.
Yeah, let's move through pretty quick.
Yeah, okay. Okay, next slide, please. So, firstly, there's a lot of people on the call here. I think we're up to 100 participants, which is great. And maybe not everybody knows what CORE is. Acronym Community Ontology Repository. We've got the O word in there, which is slightly puts some people off, turns some people off, turns some people away, whatever. Don't focus on that right now. Essentially, what we're trying to communicate here is that CORE is a community hub for structured data. So really, if you've got pretty far down the line with this and you're experiencing some of the issues which several of the previous presenters are providing commentary on here, or if you're the other end of that spectrum where you're starting out and you're looking at structured data markup, we're not just talking about, you know, schema.org wrapped in JSON LD in a web page, but there's a whole other world of structured data out there. So if you're an author of that kind of data, or if you're consuming it, or you're a linked data application developer, CORE provides a platform for pulling that kind of stuff together. It presents a low barrier to entry solution. How does it do that? Well, essentially, we do that through providing a bunch of APIs and some client toolkits, and you can sign up for an account, which is it's open source software, it's open access, and it's free to use for all ESIP members, as well as folk that are not even part of the ESIP community, but maybe want to experiment on the platform. It's funded directly by ESIP for the benefit of our community. So next slide, please. Okay, how does it fit into the session, really? So as an existing service, CORE has been pretty stable in what it's been doing. What's of note here is that all of the structured data markup at ESIP has not been, and I don't mean stable, is stable a good thing? What I mean is the structured data markup has been evolving. There's a much richer understanding from across the community now as to structured data markup. And I think that CORE still presents an appealing platform for those who want to advance what they're doing there and maybe experiment on the platform and utilize it, not just for structured data markup that we're hearing today, but also actually for some of the work that's going on within the semantic harmonization cluster of ESIP. So we're going to facilitate in this session that we're pitching for tomorrow. We're going to facilitate how people can evaluate CORE. How are we going to do that? By teaching you about publication workflows, authoring of vocabularies and mappings, publishing your ontologies, how we can do essentially how it provides a service for linked data, what the REST API is and what it looks like, what our client toolkits are like, and then what queries look like and what browsing user interface looks like. It's important for me to say as well that what we've been beginning to do over the last while is publish from these 7 kind of areas, publish more of that stuff onto the ESIP YouTube channel. So if you're planning on maybe attending this session in CORE for tomorrow, there's already a couple of videos up there on CORE that you can have a look at for the type of content. Next slide, please, Dave. The CORE cluster, same as Adam had presented here. So, you know, that's all the vehicle for structuring this work, or for, you know, making sure that we're coming together is through the CORE cluster. I'm going to mention here that there's 4 bullet points of kind of what's our mission statement, our mandate. And hopefully we're going to advance number 4 this week, which is that we are planning, to advocate the use of Core as part of powering the brand new effort which is ongoing, which is a federation of resources for earth and environmental science. You're going to hear more about that in the Visioneers session this week, so keep your eyes peeled for that. Meetings on the first Tuesday of every month. Best place to go is the ESIP calendar, as always. And next slide, please. Thank you. Finally, before we kind of conclude here, what we're going to be using the session for, well, one of the primary things we'll be using the session for tomorrow is to gather feedback on how people have been using Core, what they intend to do moving forward, whether or not we need to change our priorities in terms of more consulting with users or feature development or whatever it might well be. So that's a large part of what we'll be looking to do tomorrow. And apart from that, look forward to seeing hopefully quite a few of you tomorrow afternoon. Thanks, Dave. Back to you.
All right. Well, thank you, everybody. That was tour de force. We've only got a few minutes left here. There's been a tremendous amount of chat that will get copied into our notes. There's been some great note taking from Anonymous Armadillo. Thank you for that. Maybe it was Otter. I don't know which one of you, Tiger. But that's awesome.
It's been several people, no problem.
So we have a few ideas for breakouts here. I guess, are there ideas that have come to the top of people's minds that aren't listed here? We don't have a ton yet, that you'd like to suggest right off the bat. I think we should just jump right into that conversation.
Well, I'll jump in. Hello, everyone. This is Mark. It seems to me that this common implementation of schema.org is pretty critical, and how we might constrain that. Ruth talked about it. Mike talked about it, and there's so many information streams with this,
Right.
But trying to look at the notes, that there's a variety of different options around how we might move forward in at least providing some bounds on implementation of science on schema.org. So
I jotted down 4 potential tracks, I guess, on that. One for real-time observation data systems. We heard a few examples of collections of spatial features. I think especially spatial features that have PIDs that need to be referenced or collected. Data sets that might be identified via DOI or another persistent identifier for data. And then geosamples or water quality data that's has a little different connotation than real-time observational data.
And I should note that for my polar community that I was talking about, you need to add a 5th called all of the above and then more.
The grab bag?
But you've defined a community there, sort of, polar.
It is polar. It just happens to cover all of those
disciplines
things
within a geographic area.
So that's another, that's fascinating.
Well, but I think in terms of thinking about how splitting that, I think your ideas, Dave, are still relevant. So Polar may want to do all of those, but we're not going to do all of those over the next week.
Yep.
And I think if a strong consensus emerged on a particular one, like observational data systems, Polar would go along and would be a great test case. So I still like the way you're kind of splitting it out.
I think the regional or otherwise kind of characterization, which requires pulling in all these different types, is a really valuable use case too, though. So,
I think so. I have a question in terms of like the end game here. It comes into mind things like bioschemas, right? So they actually motivated the schema.org community to create an extension for the biological community, right? Is that where we're headed, and as ESIP, maybe in partnership with other regions, to kind of create a earth science extension of schema.org? It's a community that's very slow to change for good reason, right? They're very cautious about that. But I'd just like to know that as an endgame, it might actually be helpful for the community to have a kind of long-term vision for the activity.
Okay, so my vision is basically that we're sort of doing that, but there is some concern that there would have to be so much uptake to get them to do basically that the odds are very low. But the current guidance that's being developed in schema.org, is general. It should work for any kind of earth science data, but it allows people to do things their own way, kind of in the same way that ISO 19115 did. In other words, while it constrains to some extent what you can do to try and be more consistent within this earth science community, it's not so constraining that you wouldn't have to hand tailor everything if you were trying to do, say, for example, pull together all the polar related data records from every, repository that has that in the world. So it's sort of, yes, we'd like to, that's kind of where we're trying to be. We're trying to develop 4 repositories that have earth science data. Here's good practices, even if we haven't identified that this is exactly how you do it. Whereas the community I'm specifically talking about really wants that latter one.
So I think was that, I didn't catch who suggested this bullet that we just jotted down. I think trying to get an eye for the end game would help us with some of the incremental opportunities. I like the idea of a breakout on that, kind of not just where is science on schema.org going, but where are we as an earth science community going with structured data, so that we kind of have that big picture in mind. Because we've got all these nice detailed data set ideas and applications, but
yeah, I say that. So that was me. That was Pierre Buttigieg. I say that because, for example, when we're building this ocean information system on behalf of the UN Oceans Cluster, they want us to identify communities that can help, right? That are representative, that are working towards some sort of standardized interoperability framework. And ESIP, of course, comes to mind right away in my mind, and they're on the radar. But without kinds of like visions like that, it's hard to articulate on policy circles like where these things should be positioned. And it would be a shame not to actually channel this energy and capacity and expertise into something that can feed into these big processes happening now. Of course, if it's too early, it's best not to force oneself, right? That's also fine. It'll still be on the radar, but it's just a strategic thing.
I'm not convinced it's too early. It might be too late. I see a lot of updates to that document in real time, and I was going to comment on one that just disappeared. But this vision for earth science data use and management of structured data, if you remember my slides, I asked 2 questions. Should communities do this? And if so, how? And I think that goes directly to your visioning here. In other words, if communities want to do things like create a federated search across 81, what does that mean? Does this mean that, for example, if you're not interested in that because for your community you want to do a much more detailed set of things, that you might have to, say, put temporal information in there 2 different ways, one for the, fancy detailed, query for your own community, and another to support the broad community? You know, these are the big questions that I think this community needs to answer. I mean, it goes back to so when I'm building a fancy tool, you know, do I care about data that doesn't look exactly like what's in my repository?
So I think, Ruth, that the answer to your first question is yes. And the if so how question is really hard. And I think it relates to Dave's original meta question in the first or early presentation that relates to, you know, what is really the thing and how are we dealing with content negotiation? I mean, and so maybe we need a breakout on that. That's gonna be the meta breakout group or something on what is the thing.
Well, it depends on what you're talking about. Because if you're
I know.
Is the data set a thing? Well, it gets real problematic. But it actually is.
I know.
It's super arbitrary.
It is. Well,
that's the hardest part of it.
Well, it's super contextual. Yeah.
Right. Yeah.
You could define data set as including a landing page, and then that problem is solved.
No, I think what we're finding is that the answer of landing page is insufficient.
Yeah, exactly. That's so yeah, no, the landing content dilemma it's deeper than I appreciated, and the more I understand it, the harder it gets. And I feel well. So okay, we're over time. I don't know exactly what the rules are on going over time, but
there are no rules. We have to end. Next one's
well, I think the rule is that Dave, you and the organizers get to take all this overwhelming chat and information and come up with something coherent.
So what we're going to do is by close of business here today, we will get things in this breakout suggestions section rehashed and set into some suggestions. And then if folks can come in overnight and vote for them, or just show up tomorrow and we'll break out. I think that's probably, we've got a lot of food for thought here. I think this has been a fantastic discussion, and everybody sharing what they've been up to has been great. Been recorded, so you can share this all around. And I don't know, Amber or others, do you have any?
I think if people are willing before they leave, they could put a +1 at the end of one of the bullets for which of those breakouts they would be most likely to attend, and that'll give us a sense of where the interest is.
That'd be great. And if there are topics in the notes that you think would make good breakouts, throw a comment on something up in the notes. I just don't want to lose any particular topics if folks found them especially compelling. And like I said, the discussion that's been lively in the Zoom chat will also get copied into this doc for posterity. So.
All right. Say goodbye, everybody.
Cool. Thank you. This has been great.
Well, it is 8:30, so let's go ahead and get started. I'm going to share my screen so that people can see where we are at, but I am sure that you have navigated your way successfully to Kiko by now, with it being the second day of the meeting. So welcome. This is the Structured Data on the Web session. It's part 2. We started off yesterday afternoon, and so we have this 1.5 hour chunk right now, part 2, and then we have a break, and then we're moving into part 3. Just a little bit of a quick orientation. Some of you I know were with us yesterday, some of you may be new to us today. The agenda is here. We have lots of embedded links within this document to help you bounce around, because we're using the one document for all 3 parts, and so we know that it's going to turn into a behemoth of an activity, but at the same time we have done as much as we can to help support you. So today what we're going to be focusing on is looking at forwarding progress on meaningful application with respect to structured data on the web. And so we're going to do that through breakout sessions. And so right here in this agenda, you can see that we have a link out to the notes, and I'll take you there in a moment, and a link out to some slides. Again, this is the same slide set as yesterday, so we're starting at slide 77. So when you go to the notes, this is the notes for the general conversation that we're having right now, and then also the conversation that we'll be having when we regroup after the breakouts. And then we have links to breakout notes, and you'll see that we have an option C. We're going to have some discussion as to which breakouts we're going to be running this morning. And of course, you can get back to the agenda and back to the slides, or to the slides that way. So with respect to today, what I wanted to do is to invite those individuals that are going to be leading the confirmed breakouts to talk a little bit about what they're doing. And I'm just going to move over to the slides. Can you all see these slides?
Yes, we can.
Yep, great. To talk a little bit about what we were planning on doing. And so at the end of yesterday, we had some fantastic discussion, and there's a lot that can be tackled. And so we went through the notes that were in the document, and we went through the notes that came in via chat, and we kind of organized and consolidated those to determine two main areas that we think would be valued in a breakout session. And the focus of part one really is on the application or the implementation. And so we're looking at a breakout focused on regional repository interoperability, and then also one that's focused on spatial features and observations. And our intention during the breakouts is for those sessions to potentially run into the session after our break, into part three, where you'll have the opportunity to discuss more technical solutions to these challenges and interoperability considerations. We also have a proposal from Lewis that there'll be a session in part three focused on core, which is again a more technical conversation. But we're absolutely open to conversation around other breakouts that would be valuable to have during this first part that again can lead into the second part, or thinking about those technical pieces that would be valuable after the break. So before we go into that discussion, I thought it'd be really useful to have a good sense of what's going to be covered in sessions breakout A and breakout B, to inform a little bit of a conversation before we make final decisions. So I'm going to move on in the slide, but pass over speaking rights to Ruth, who's going to talk about the regional repository interoperability.
All right. Okay, so this is something I actually briefed during yesterday's session. And the issue is that if you are a group of repositories who would like to be able to have all of your members, in the case I'm thinking of, which is the Polar Data Community, there's roughly 81 repositories involved. And you want to be able to find all of the data in all the repositories in the world that is about, a polar region, for example. You need to be able to federated search. Now, what you're seeing here is a description of the problems that I talked about yesterday, which are that, standard metadata isn't really standard. Everybody implements ISO 19115 differently, so that if you're trying to aggregate all of that data together, all that metadata together, you end up having to hand tune every new repository that joins, and it's because all of these things are being done in incompatible ways. And more than that, it's very circular, that many aggregators are harvesting information that has already been harvested by somebody else. And you can see both of these things in these images that I've put on the slide. The image on the left is showing all of the connections of who's harvesting from whom in the polar community, and you can see that it's highly circular. So many things are getting harvested many times. So you can see, you know, some nodes like Data One and NCEI and GCMD and the Polar Data Center in Canada and GEOS are, you know, extremely well connected to lots of other places, but many places are harvesting from other places. So that leads to an issue where what's the authoritative copy and where should I go to get the data? And then the slide on the right, or the image on the right, is a very partial picture of something we tried to develop during a meeting of the polar communities. And what you notice is that even though we haven't really fleshed out how many aggregators there are, or even how many repositories there are, the number of technologies in use and the number of protocols they're using to harvest or get metadata available from someplace is large. And that means doing an actual simple time, space, and parameter query extremely difficult to get implemented. But so the question is, you know, what are repositories willing to do to allow these kinds of much larger queries across, you know, repositories in order to support, you know, communities in this particular case based on, you know, location on the globe. And that's the question. And if you're interested in trying to answer it, please come to that breakout session.
Fantastic.
Hey,
Thanks,
Amber.
Ruth. Yeah.
Can I ask a question to Ruth before we go on?
Yeah, please do.
Or is that because maybe I wanted to do it outside of the breakout just because other people here may have answers. But Ruth, this is the second time that you said in the last 2 days a sentence like, everyone implements ISO metadata differently. Everyone differently. I'm really curious about what data do you actually have about the differences in, or the supposed differences in those implementations that you're mentioning. How did you collect that data? And do you really have anything that we would consider to be support for that statement that's really quantitative, that we can look at and understand how big those differences are, or how important they are, or what use cases they might affect, or are they really differences? You know, whenever someone says everything does something which is standard differently, it's very easy for people to say that, but without support, it's really meaningless.
Okay, so I guess I have a lot of answers to your question because it's a line of reasoning that has come about over a long series of meetings and work. So the first time I ran into this problem was several years ago now, when we were trying in the BQ project to basically broker data, and discovered that, you know, every time we had the Italians, I forget the name of their system, add a new repository, they had to hand tweak their mapping to ISO from whatever version of ISO that repository was doing. So that is all from that project. Also, as part of that project, we did and this is a very embarrassing thing for me to admit, but Ted, I think you've heard it before. And that is that we did manage to actually run a really huge query, or I should call it query. We did a crawl of the metadata space on the web and found 1 million Earth science data sets. But I lost the data set due to the fact that it was on Amazon and my grant was over, and people started heavily using it at the $40 an hour rate, and my grant was over. And we had been trying to find a place, because it was a pretty large database back then, you know, because it was way more than a terabyte. But anyway, so that data is gone, but we have the results of a number of Python scripts and stuff like that. And there were huge problems, from how do you even know what data set this is, to things like, you know, one of my favorite examples was metadata from Italy that had some French in it, that kind of pointed to the data being in England, but when you went to those records, it actually was a Goddard Space Flight Center. So it was very circular. And then NSIDC developed the Arctic Data Explorer, which is one of the items on this picture here, ADE right here. I don't know if you can see my cursor, but and that was the experience we had at NSIDC. Oh, somebody is moving my cursor for me, or their cursor, or something like that. Anyways, wow, that's very weird. But anyways, that was the experience that that was had at NSIDC, is that and they had like 15, or at the time, I think, repositories. Not all of them show up on this diagram, but some of them do. And then last but not least, this is also something I've heard from people who are doing aggregation in the polar regions, such as Øystein Godai from Met Norway, who also is doing the aggregation for the Global Cryosphere Watch and WMO and some major programs. So those are the 3 lines of evidence. Can I say categorically that no 2 repositories implement it the same way? No, I'm not really saying that. I'm just saying that the heterogeneity is enough to make it very problematic.
Well, I don't think we're saying, Ted, that, well, here's my experience on that topic.
Hey, Doug.
I think we're all compliant, but ISO is flexible enough for people to say the same thing in different ways. But you're absolutely right. This has to be measured for it to be a thing. If it can't measure it, it doesn't exist. So are we doing anything about that, for measuring this variance?
Well, you know, I think that that's really true. And I think if, you know, when someone like Ruth, who many people listen to, makes a statement without measuring anything, it's very difficult to judge how correct that statement is and what the real problems are. And so we can wander around and say, you know, everybody's doing everything differently, but until we have actual data about what those differences are they differences are they invalid records? Are they just differences in content? Oh, no, they're not invalid records. Or is it, you know, are there inconsistencies in the content? Certainly. But you know, I'm also working with Bill Manley and Allison on the polar metadata problem there. And the problem is not that everybody's doing ISO differently. It's that the much bigger problem is that people are using many different metadata standards and different vocabularies and things like that. So if you're, you know, when you make a statement that you made twice now about ISO, it seems like there's a problem with ISO. And really, these are problems with metadata and non-standard metadata and the ways that things are implemented. So I would really appreciate it if you would be more careful with your terminology when you're bashing a standard than you have been.
Consider it to be bashing a standard, but if you're thinking that I did, I apologize. I also note that you'd be much happier if so I didn't publish the paper about those B-cube results because we lost the data due to the factor it was costing $40 an hour. But
so Ruth, I think this is a really interesting conversation, and I think that what you were saying, Ted, about the quantification and the reason for the differences, and it's an important discussion. To make sure that you have adequate time when you're in breakout to get into these details and the other group has adequate time, I'd like to move on just to present the other breakout option that's in front of us, and then you can continue the discussion momentarily, if that's okay.
Thanks, Amber.
So Kyle or Mike, I'm not sure who is overviewing the other breakouts, but if you're able to turn on your mics, that would be great.
Sure, this is Kyle. I'll take a stab at it. Mike, feel free to jump in and correct me if I misrepresent anything. The idea behind this breakout is that when we're talking about Earth observations, there's things in the world, there's locations and features of interest that are real world things that folks are generating data about. And then there's how organizations represent those real world things when they're publishing data and metadata. And there can be a lot of variability in those representations that can make it very difficult to sort of build a knowledge graph. There's Mike's example in that the U.S. Army Corps of Engineers might represent a dam as a feature of interest that there's a lot of data about, and that dam might be represented by a point location somewhere. And the Department of Energy might have data about that same dam that they represent, maybe with even the same identifier or identification scheme, but they represent that as a slightly different point on Earth. That's a few hundred meters off. And others might represent that feature as a polygon with a different identifier, and so on. And so in this group, we're sort of, we are tackling the idea of there being sort of common reference monitoring locations and features of interests that organizations' own representations can link to say that their metadata and data resources are about. And there are a lot of kind of issues with that, because when we're talking about the internet, that often comes down to meaning landing pages. And this gets into the earlier discussions from yesterday we had about, what is a landing page? Do we want the landing page's identifier to be the same as the thing it is ostensibly about? And this problem that one person's metadata is another person's data. And I'm not sure do you have anything to add, Mike?
No, I think just maybe on the features of interest, that there's equally the way that it's represented. You were saying, so to one group, the whole system of dams protecting water or controlling water around the peninsula-ish area there is of what's interest. For other hydrologic modeling communities, each individual feature. And then there's also a level of precision in the location that's kind of showing up in a lot of the data sets. Some agencies that contribute put the dam or the feature really close. Another one just kind of click somewhere on the map because the location isn't what's of greatest interest to them. And then so how do you kind of conflate or bring these two different discrepancies together? Or how do you prioritize what might be a better representation versus what might be less good? Other than that, I think you nailed it.
Great, thank you both. Okay, and so okay, this is not escaping, there we go. Okay, so those are the two that came out of yesterday's discussion. We do have the opportunity to consider any other breakouts if someone has a topic that they think would be valuable and would be in a position to lead a breakout activity. As I mentioned, these breakouts can follow on into the session after the break. We can also bring in some more technical conversations, for example, core. And just taking you back to the notes, one of the things that I wanted to highlight in the breakout is that the conversation really should be thinking about the problem space, defining that, exploring what is solvable, and then also thinking about how to build from that into the next session after the break, or if you've reached a point of completion, to recognize that. So with that said, are there any other nominations for other breakouts that people would like to pursue?
Amber?
Yeah, Ted.
This is Ted again. I would sort of like, I'm curious if people would be interested in a breakout about tools that they're using for dealing with structured data, for creating it, and maybe either web interfaces or creating it on your laptop in a file, or validating it, or yesterday Doug mentioned Shackle, which is an interesting thing, but or what are useful tools that can help people do structured data well.
And is that something that you think would be valuable to have during this session, or perhaps during the after break session when we've kind of had some conversations around interoperability and spatial observations and features?
Yeah, I mean, that would be a second question. If the group wanted to do it this time, that would, either time would be fine for me. It's just something that I'm sort of looking for those tools and could use insights from people that may have experience with some.
Yeah. Thoughts from anyone else? So my sense, Ted, I mean, this is a personal opinion, is I think that sounds really interesting. I think that we might have overlap of people that would be in the interoperability session that might be interested in both that and the tools. So would you mind if we put that as a breakout for part 3?
No, that's fine with me.
Okay, fantastic. Okay, so with that, we have the 2 proposals. I want to give you some information about how this is going to work. You have your session organizers. To be able to decide which session to go to, or to let Megan know, if you can use the rename option. So if you go to your panel and click the 3 dots, you'll see the option to rename. And if you rename yourself according to the session that you want to go to, it'll take just a moment or 2 for Megan to organize everybody. And I will stay in this room to help people move into their breakouts. But the sooner that you rename, the sooner you can get your conversation started, and we'll just continue to add people if people join in this main room. We do want for everybody to come back about 15 minutes before the end to provide some kind of roundup reporting, to kind of share across that information and to talk about next steps for the next session. "74 participants, and I can see you all frantically renaming yourselves. This is great."
And there are 7 people watching the live stream. For the folks in the live stream, unfortunately, you can't view the breakouts.
So you're not going to stream the breakouts?
It's not possible to stream all of the breakouts, no.
All right. I know one person who was out of luck then. I'm just going to tell her. Well,
If that person is dialed in by phone, they can be put into a breakout. But if you're just watching the live stream, I would suggest we will start the live stream again before the final discussion.
And they can follow along in the notes document. So it's not as engaging, I understand.
So Amber, we still have just 2 breakouts, correct?
Correct, just A and B.
Okay.
We have a couple of people popping their options into Zoom chat as well.
I see someone on chat has renamed themselves A. They've gone all in.
That's helpful.
Indeed, no point in being tentative, but nobody has renamed themselves C. So, you know.
Ah, Lewis, choosing the case.
And if anybody goes into their room and for whatever reason isn't where they wanted to be or wants to hop somewhere else, you can always leave and come back to the main room and I can put you where you'd like to be. All right, there are definitely quite a few people who haven't indicated with their name.
So Megan, why don't you pop everyone that has indicated across and then we'll work through everybody else from the chat and one-on-one interactions.
How much time would you like these rooms to have at the moment?
At the moment, probably 50 minutes.
Okay. All right, so some of you will...
Hi, this is Rick Webb. I can't see the three dots. Do I have to turn my video on before being offered the three dots?
You can also try...
Which room would you like to be in, Rick? I can do it for you.
No, you don't have to turn your video on. Mine isn't, and I was able to do it, but I'm on the Zoom application rather than the web.
If you hover over your name in the participant list, a more shows up to the right, and if you click on that, you also get the rename capability.
We can help people that haven't been moved in just a moment if Megan moves people across. Rick, did you want to go into A or B?
B.
B. Okay, I'll do that for you.
There. There's somebody named Everyone. All right, let me look at the chat box now. Let's see, Karen, you said A. Great, thank you guys for renaming on the fly.
Hey, I'm here now. Slightly with it.
Oh, hi, Dave.
See you,
You're
Dave.
in B.
I'll put you there. I'm also going to make you a co-host, Dave.
But before you send me off, how did the first part go?
It was great. We had a suggestion come in from Ted Haberman to have a session on tools. So I propose that we have that in session 3 because I think there might be overlap with people that are going to be in the interoperability group. So right now it's just those 2 sessions that we had identified following yesterday, and we're just moving people now. It went long a little bit because we got into some of the nuances of how we define the differences in the way in which people are using ISO. And so we're a little bit behind schedule, but.
Okay, Dave, I'm gonna move you. I'm sorry to interrupt, but I have to get to these other 6 people and figure out what they're hoping for.
That's great, go ahead.
Or you don't have to leave actually, but just hang on one second. I wanted to see Adam Kennedy. Do you have a preference? Or anybody who hasn't moved yet, Rob, Melissa? Otherwise, I'm going to throw you somewhere, and if you don't like it, come back. I'm trying to see how many people do we have in each room. It looks like B is maybe slightly smaller than A, but they're pretty good size.
Great.
All right. All right, here you go, Dave. Melissa. I don't know who that is. All right. Everybody's been offered the chance to join a breakout room.
Fantastic. I see that some people have not yet taken you up on your offer.
I wonder if there are a few people maybe multitasking.
I know, it happens.
I know yesterday somebody asked, I should pause, hold on a second. All right, they have 60 seconds to leave.
Okay. Nope, coming over. Welcome back, those of you that are coming over. Obviously, we're going to wait for the breakout rooms to close and everyone gets put back here automatically if they haven't done so voluntarily. So I think that'll just be a few more seconds.
Hello, Amber. I think we're back.
And we're back.
Yes, the rooms are now closed.
Okay.
Okay.
I got a
Okay, the
whiff
count
of
is still
watching a
going up,
SpaceX launch there when you said all the sub windows are now closed. Cool.
So I presume we should give a summary of our breakout session. And I think Dan had...
Yeah, I was just watching.
Yes?
So go ahead. I was just checking that the participant count had slowed, and it has.
Okay. So we had a pretty wide-ranging discussion, but have eventually coalesced back around the question of basically that schema.org is a simple enough technology that you know, if you have a website at all, you should be able to, at least at some point, given the suite of tools that's being developed, be able to implement it. And the question is that schema.org, like many metadata standards or whatever, allows a lot of options and leaves a lot of room for interpretation. And while the schema.org group here at ESIP is, you know, sort of wading through that and making some recommendations, those recommendations are not probably simple enough or explicit enough to allow a simple federated search across all sorts of communities, ranging from the very large to the very small and not too technically sophisticated community. Yet there is a desire to be able to do a search across all of those as one use case or an initial use case. And so the question is, can we socialize within ESIP the ability to query across a wide variety of resources in a standard way? Basically time, space, and parameter being the ones that communities have currently asked for, that does not leave out any repository at any scale, from, you know, basically heritage centers that have, you know, a web page to, you know, your NCEIs and your GIOSs, etc. And to do that, how would we do that? And I would say we actually didn't get to the answer to that. And Dan had tried to summarize it, but I don't see his summary exactly in our notes yet. So Dan, you might want to put that in there. But that's basically where we're at. I think we've finally gotten sort of to the, you know, agreeing at least what the questions are. Though I don't think we've gotten to the any sort of answer at this point.
Sounds like the goal of the first session was to bottom out some question and figure out what you want to talk about next. So cool. And that actually, so I'll go ahead and summarize the second breakout, and then maybe we can, and we only have a few minutes left here, but there might be a few minutes to think about what to do next. So the breakout on observations and features was somewhat wandering, exploring use cases early as expected, and I think that was good. Then we kind of dug into some details around how people are implementing this distinction between a knowledge graph and a web API, kind of at two ends of a spectrum. And there's a lot there. And there's a lot of different pieces that we need to worry about. And so that was interesting. We talked about a bunch of tech, a bunch of different details. And at the end, we kind of circled back around and said, well, what's the role of a landing page for a spatial feature? And so Fran Lightsome had basically suggested, and I think this is really good, that the role of that landing page right now is to tell a person that they would want to tag their data with that feature. They would want to say, my observational data was observed on that river. My data was collected from that well. I collected data about that ecosystem, right? Whatever it is. So the landing page's job is really just to give the data provider the information they need to know that they should tag their data with that feature. So we kind of ran with that notion as a bit of a central tendency. And I think we're going to take that forward. And the basic question, so coming to something Doug was talking about in his lightning talk on IGSN 2040, and something we've talked about in the Elfie-Selfie interoperability experiments is, can we define JSON schemas that happen to be JSON LD and would give some guidance to web developers of what linked data to embed into their web pages for observational data, and how to link to these reference features that we're starting to publish. So I think that's where we're going to go next. So we're going to talk about basically how do we drive adoption of embedding linked data into landing pages, and use these reference features that we're getting published kind of in anger to start to build the big knowledge graph that's just on the internet and can be discovered through crawlers, to set up this potential that systems like Grow, Gleaner, the stuff that Doug's been working on, various other crawler technologies, obviously Google, have the linked data content that they need to start to build out the richer linked data graph. So I think there's some good stuff to talk about there in the second session, and I think that's where we're going to go. So I guess we should probably step back and say, does anybody have anything to add to either of those summaries that Ruth or I gave?
Dave,
hey.
This is Ted. I think in breakout A, there was general. Maybe I'll ask the group if they thought there might be general agreement on ISO 8601 and well-known text for representing time and space, with the exception of paleo or geologic age. So in representing time, you might need something that looks like a string, which is the name of some epoch or epoch, as well as 8601. and we found out that, you know, the cool kids call well-known text wicket.
That's just me. So. Ted, I would just say that instead of 8601, I mean, typically we're looking at things like Al time, and I think Al time scopes things like 8601. It scopes the geologic age. It scopes other you know, more shallow time issues like before present and things like that. So,
what was it called?
There was another
Doug?
system that came up the last time we were working through that too, and it. But I didn't see Matt around. But
so this sounds like a great topic for the second breakout.
Yeah.
Al time is the only thing.
No, but it was something other than Al time. That
ALTIME.
Time came up in our breakout too. And actually the question was, is there an opportunity to express a temporal existence period for a place in schema.org? So that's maybe a little common thread between the two.
Right. I mean, Al defines a more of a temporal topology type thing with a reference system in it. So, but that's a digression.
Hey, Doug, could you spell that?
Al, A-O-W-L time. Al time.
I'll send you. Okay.
Yeah, it's the W3C Al time.
Yeah. Okay. I thought it was Al time.
It's just on the Midwestern.
Al time.
So just a quick comment on that from Chuck. There's also some extensions that Simon Cox and actually Adam Shepard and I have been working on in terms of temporal aggregates. And then Simon did temporal relations, so that you can basically say that two periods were coincident with one another, or they were contained within one another. These sort of more complex relations. So there's the original Al time, which is basically a way of being able to say a time is an instant, or it's something more complicated than an instant. And then there are sort of building blocks that are W3C, OGC, you know, sort of technical reports or recommendations, or, you know, beyond that, actual, you know, OGC standards, right, that then tie into that. So the issue is that in schema.org, I mean, you have very simple sort of relations. So you'd have to build some bridges between schema.org and these other sort of web standards in order to be able to start to say more complicated things like that. But the machinery is starting to be built to be able to do that. Just like
one of the things that I think this group should notice is that both discussions involved a socialization issue. And obviously, I don't think we want to pull socialization in two totally different directions without being, you know, very conscious of what we're doing. So I actually personally vote for somehow coming back together and making sure that whatever group B is doing works with whatever.
I think we should plan on having the outcomes of what we're talking about circle back to other ESIP groups. We're not talking about doing anything new here. I think we need to circle these back into something central. And obviously science on schema.org is one of them, but there's probably one or two others. So it's a good.
Agreed.
Good, sure. Very good. Or is that our time?
That's our time.
Beautiful.
We have in the Google Doc that I'm sharing on the screen, we have essentially 4 suggestions for breakouts activities following the break. And I actually wonder, based on your comment, Ruth, and the conversation, whether at this point there's a value in bringing A and B together during the next session, because we also have a suggestion for tools for structured data and then the core work that Lewis is leading.
It also sounded like tools for structured data may be covered by Dave in the schema.org session this afternoon. Is he still here?
I'm still here, partially, and it's going to be fairly technical, probably.
So what?
That's okay.
I'd like to keep a focused track on the JSON schema for observations and features. And I think it sounded like there was probably some worthwhile further conversation in the work that Ruth was talking about. So maybe keep those two separate. And we had a lot of people in these breakouts. So I guess I think we've got space for more.
Okay.
So.
All right, well, we'll get this set up ready for after the break then.
All right. I will see everybody in
hour.
I will see people in a half hour. Well,
So
27 minutes.
This Zoom will not close. So if folks just want to mute and turn off their screens, or if you want to continue to have conversation, I'm going to pause the recording and stop the live stream. But stay here or come back in 30 minutes or in an hour. Sorry.
Thanks, Meg. Listen, folks, just before we break here very quickly, if you do have an interest in core, can you please indicate in the chat box, and so that we know whether that's going ahead or not. Everything's prepared for it.
The initial schemas that we developed for some of the IGSN testing that we
If you could, I think that'd be helpful for this next conversation. Yeah, and I think really we just want to see where would we circle that stuff back, and I think the prospect could be some, like, this is how you use the science on schema.org guidance in JSON schema. And Adam, does that make any sense? Does that throw any red flags for you?
No, not for me. No, that's cool.
Okay. Because that was definitely an outcome of the work that we did in Selfie, where we're like,
Did you
wow,
guys
a
make
lot.
schemas for that, Dave?
No, we didn't. But basically, it was like, look, if we want adoption, the easiest path on this is going to be JSON schema fragments that describe the content that we're talking about.
So I find that interesting that was an outcome from that, right? You know, because it was something that came up, you know, a lot within the IGSN sprint, and I have to admit it was kind of new to me, having not really done much with JSON schema. Right.
Now, the problem becomes when you also want to validate relations, right? And so in our little web application, we actually build a little mini graph to add in other information about other entities, right? And
I appreciate that. Yeah.
To validate that, we can't necessarily just use JSON schema. So that's where the shackle shape comes in.
I totally agree with that. But my only point I would say in defending the approach is that if part of our argument for JSON LD is that it opens us up to the broad ecosystem of JSON tooling, then ignoring JSON schema seems not wise.
I hope I wasn't advocating that.
Yeah, no, there's some major, I mean, gosh, this is
the issue is that these are all views of the data, right?
True.
And so you can create views at different levels, right?
Totally
and
agree.
So the problem is that when these levels start to get mixed up, that then things become a big hairy ball of mess, right? And so my only point is that you want to be explicit about separating out concerns so that a smarter agent, right, which we all hope that eventually we're moving toward, can then make, you know, more informed decisions about consumption of the data, right? And
no, I totally agree with that. I mean, there's a potential issue, I suppose, for conflating schema and shackle, and I don't think that they are different. They're definitely not mutually exclusive. I mean, they have their own rules. So
yeah.
I think we're all in agreement in that.
Let's take this to the breakouts. I think we need to get going here.
Yep.
But that
good chatting with you, Chuck.
Nice chatting with you.
That set of concerns around treating JSON as RDF versus JSON as JSON. There's just so many different competing demands around adoptability and precision of semantics and blah 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 that we need to be worried about. So let's keep talking. So I think we're ready to get going. I see a few people coming back online for real. So during the break, Amber has been getting things set. And I was just kind of verifying some assumptions with a few folks that were here over the lunch break. I think the plan was to, for those of you, hopefully most, if not everybody, was here for the first stretch of breakouts. The plan was to kind of continue those conversations, but take it to a little more technical next steps. What can we expect to achieve as a community, and where can we take that where can we take that conversation to move a ball forward? And then we have 2 more potential breakouts. The first session, the breakouts were quite large. I think there's definitely space for more subgroups to form. So I guess I think we had Ted was.
I'm sharing a slide right now, and we were going to invite Lewis and Ted to give a kind of a 1-minute overview.
Perfect.
We don't need to do the same for the ones that happened already, because as you said, it's a continuation.
So is Lewis, are you around? Well, maybe Ted, you can go first. And
yeah, I mean, I'm sort of a newbie in this structured data part of the world. And so I was just curious, what tools a couple people during various sessions have said that one of the wonderful things about JSON LD is the extensive tooling. And I'm trying to discover what part of that extensive tooling people are finding useful.
Okay.
Like if they were creating structured data, I mean, there's certainly web services for reading JSON, and I'm more interested in maybe the creation and validation and et cetera side.
So probably stuff like the JSON LD playground, or maybe some other pieces of kit.
Yeah,
okay.
Whatever.
Yeah.
And then I see Lewis is here now.
Yeah, Lewis.
Thanks, folks. So it sounds, Ted, as if, honestly, as if some of the previous sessions which Adam and Doug have given on the tooling which they've developed around about scienceonschema.org are certainly relevant for that session as well.
Yeah, and I know that there's going to be some discussion of that I think in the next session. So if that, I'm willing to forego. But Dave said that he thought he was just going to touch on a couple things.
Mm-hmm. Yeah.
And I think, I don't know if Dave's here, but his tool, it seems to me, is right now for harvesting schema.org from web pages and doing something with it. But if I'm trying to create structured data
from the ground up, yeah, we're actually working on a tool like that internal for JPL data providers, data authors, and we've got a data curation team that we're delivering that for. So it's very relevant stuff, Ted. Yeah. Okay. So the session which Carlos and I had proposed was really somewhat building off of where you're going, I think, Ted, with part of what is available through Core is the ability to author semantic resources. It's not schema.org, sorry, JSON LD as such, but it's vocabularies, mappings, and well, arguably when you evolve those things, they become, ontologies as well. But really, these 7 boxes or 7 topics on the bottom is what you'll be leaving with, hopefully, from this session is you have undertaken more of an evaluation of how useful the core platform is for you. We'll go, as I said, we'll break down to that, and then towards the end, before the 15-minute regroup, I wanted to spend about 10 minutes to get ideas from people about what they would like to see Core do, or if they've got use cases that they want to come forward with, and stuff like that. So that's really, in essence, what we're planning to do here. I will say as well, there sounds like there's a bit of overlap. Ted's really focused on the tooling for developing maybe JSON LD and schema.org and stuff like this. There's part of tooling, as I said, is in here. I'm just going to say it up front here as well. We're willing to forego this session Why? Because there's potentially an opportunity for this to be, for this session to go ahead next week's Visioneers session. And I don't know who's planning on attending that one, but there also is a slot where we could maybe fit that in if we want to focus on the two, you know, continuing with some of the threads from earlier this morning. So I'll leave it there. Thank you.
Okay, great. Thanks, Lewis. So for those of you that were here this morning, the same process in terms of identifying the session that you want to go in. Maybe, you know, with respect to what you just said, Lewis, if we find that your breakout session is small, then you can make the decision over there to come back. And if you have a good population, then kind of move forward with it. So for those of you that haven't done this before, want to hear earlier, if you go to kind of your name in the participant list or scroll over your video or your picture, 3 little dots, you'll have the opportunity to rename yourself. Please rename yourself according to the session. Erin is going to start assigning you based on the suffix that you provide. It takes a little bit of a time, so just be patient. You'll all be in your rooms shortly. Anyone that's having trouble, once we have the majority of people moved over, we'll help with you on a one-on-one basis. If you're not able to do this, we can get you assigned as appropriate. And you'll have one hour. Oh, sorry.
Sorry, Amber, you said me, but I think Megan's doing it, right?
I'm doing it's Erin Robinson. Hey, Erin McLean. 2 Erins. Yep, I'm putting people into rooms. I'm gonna go ahead and okay, as soon as I get people sort of, maybe take 30 seconds, rename yourself because things are jumping a little bit. So if everybody can rename quickly, and then whoever's not renamed, and our phone call-in user, if you want to *6 and unmute yourself, or I can unmute you. I just unmuted our call-in user. If you are just on the phone and you want to tell me what breakout you want to go to, I can put you in that breakout too.
And you'll have 60 minutes in breakout, and then we'll be back for a report out and kind of a summary and next steps.
Good dog.
Erin, this is Ken. Can you hear me?
Yes, we can.
We can hear you. Hey, Ken, what group do you want to go to?
Yeah, quick. Are we able to go? Is it all 4, or is it only the C and D at this point?
All 4.
Okay, I think I'd go back to the regional repository one, Group A.
Okay, cool. I will move you there.
Thank you so much.
No problem. Okay. I think I'm probably not as efficient as Megan. So Group A is still pretty big, just for what it's worth, guys. Everybody's doing a great job of renaming.
Lewis?
Okay, so I'm going to open the breakout rooms, and then Vardis, Amy, I can move you guys in just a second, but it looks like everybody's right. Okay, so we will see you guys in an hour. Is that the instruction?
Sounds good.
Sounds good. Bye, guys.
Pierre
is going to A, Lewis.
Okay, that's great. I thought, Pierre, that you had tried to talk to me there. Maybe
that's the question. The question was, would you like me in the core room? Because if A is big, I can go to core too. I mean, is there anything that I can bring from the ontology development, or?
It's more the how, I would say, rather than the what at this point in time. At this point, Pierre.
Sure. I'll hop over to A then.
You're good. Yep, you're good. Thank you, Pierre.
Can somebody move me to A? I think I clicked on the later, and I think I'm still stuck here.
Hi,
I'm
Eric.
not stuck with us, Pierre.
This is Vardis. How do I move into the one of the breakout rooms?
Hey, Vardis, so you tell me which one you want to go to.
I kind of just joined, so I missed
Oh,
just pick
Amber,
one.
can you?
Pick one and put
Yep.
me in there. How's
Okay,
about
I'm
that?
gonna move you to tools to start with, Vardis, and then
Sounds good.
if you don't like it, come back.
Okay. Okay. So do I get out of the current Zoom or do I?
Nope, stay here and you'll just get a pop-up that'll say, do you want to join this?
Okay. Perfect.
This
Thank you.
room. Yep. Looks like, so Amber, looks like everybody's doing great. Rob and Angela, where do you guys want to go? And Vardis, you should have seen a pop. There should have been a message.
Yes, join room 4. Excellent.
Perfect. Great. See you later. And
hang on, guys. I'm gonna mute for another minute and then I'll be back.
Rob, we're just joining breakouts and they're shared on the screen. So if you want to let me know which one you want to go to, I will shift you into that room.
Thank you. I'm going with A.
Oh, A. Great.
Thank you.
Amber, where do you want to go?
I was actually staying here to help anyone that had questions as they came in and direct them accordingly and doing
That
some
is
work
awesome.
on Google Docs.
Great. I love that. Angela, if you want to go into a breakout, just let us know. Otherwise, cool to just sit quietly and work here.
I like to go to D.
Okay, you got it. And we had one more person join. CD Cesar. We're in breakouts. Which breakout do you want to go? Almost. Oh, hey, Christina. And Carlos. Carlos, I'm thinking you're probably going to want to go to core. I'm going to move you down there. You can unmute if that's not true. And then Christina and Dave, I can move you guys to breakouts. The breakouts are on the screen.
Yeah, so core is ontologies and semantics ontologies.
This is the breakout.
I'm just going to go for it with Carlos.
Structured data tools.
Okay.
Carlos can come back if he's, could I join tools? Yes. Christina, I'm putting you in tools.
Peter, what's your last name? What Peter are you?
And, okay. Steve, we're in breakouts. Which breakout do you want to go to? And Dave, same question. We are in.
My God.
Oh my gosh. We are in breakouts. Steve, I'm happy to guess for you, but if you want to tell me.
This is a meet together instead of hanging together, maybe.
I just put
Okay, David is in D.
Okay, great job. And
Maybe.
Steve, you just put it in.
Okay. Okay, so Daniel.
Steve, where do you want to go?
Notes document. Hey, Peter, how are you? So my experience, and the reason I wanted to ask this question is because I've done a lot of work in dreaded XML land, and I use tools like, I use mostly Oxygen, but another tool was XML Spy. So these were very sophisticated environments for creating and validating and transforming and basically almost everything that you might want to do with data in XML, you could do in those environments.
Aaron, do you want to go on mute? We can hear Ted. Not that it matters, really, but there you go. I'm
Yeah,
not sure
I'm
whether-
waiting to see if Steve is going to come back, but yeah, I'll go on mute.
Yeah, I figured that I could manage the conversation with people, and if you're listening, then you'd be able to assign. So Steve, I don't know whether you are able to hear us. We're just wondering which of the 4 sessions that are on the screen you have an interest in attending. because we're in breakout right now. There isn't activity happening in this main room.
All right, hold on a sec.
There was general agreement that having examples of people doing this to, draw from is useful, and that there now are many of those, some from EarthCube, the Sea Caddy project in Canada, and some other projects. And having a group who's interested in actually implementing this stuff, which the Polder community is, once we have that guidance, is good. And they're willing to go and be that, thing that brings, has the examples and stuff for everybody to do. Also, there are some people who have volunteered to help with this. For example, the oceans community and the polar community have some overlap called the Arctic Ocean and the Southern Ocean. And so they're willing to help make sure these things are organized. Pierre is willing to help. He actually has a little bit of funding for this kind of stuff as well. So, so I think there's general agreement. We're going to create profiles, and so we want to do this in a sort of general way. And I noticed that the samples folks, it would be good if we were, coordinating with them as well. So we have a plan for moving forward is, I guess, the final message, for actually getting best practices to be written and implemented and socialized up and down and around. So, which was my goal. So I'm happy. That's my report.
That's great. So I'm actually seeing some convergence here between these two sessions, which is fantastic, and maybe some really parallel work that we could focus on. So I jotted down some notes from what you were talking about, and I'll just quickly, so our breakout was a little bit of say, what are we doing here? And we've, both from the comments we got yesterday in our lightning talks and from today, I think it's clear that the stuff we're doing in geoconnects.us and geoconnects.ca appears to be biting off an awfully large chunk of scope, which is true. This is pretty ambitious, but we're doing it in the context of a lot of buy-in, and that's really exciting. So we talked through that a little bit and just kind of where we're at with GeoConnects and having various kinds of reference features. And we got into a good conversation about the distinction between geographic location and place that has a specific type as defined in some domain. So a bridge is coincident with a dam, is coincident with a stream gauge, maybe. They're all the same geospatial location, but there are three types of place that happen to share location. So we got into that, which is, it's a tricky detail here, because things are indexed spatially, but we also want to be able to index them according to these kind of place-based types and characteristics. So how that fits into schema.org, how that fits into kind of web parlance is tricky, and inevitably we end up talking around it a lot, because it's just tricky. So in our wrap up kind of takeaways, let's see. That's probably, that's a bit wandering, but that's a good summary of the conversation. Wrap up and takeaways. I think I'm going to take away the task to open an issue on scienceonschema.org to start to think about how to link to 303 redirect PIDs within the context of the scienceonschema.org guidance. And I think that actually tracks nicely with what you were talking about as schema.org profiles. And then I wonder if we couldn't look at that as an exercise to start defining either and or shackle shapes or JSON schema fragments for these profiles. I think that would be a pretty productive way forward there. One kind of interesting question that's just open, I think, is how does DGGS, this discrete global grid system, intersect with all this? Because it turns a kind of complete spatial reference system into a set of features that are also refinable, which is really interesting when we're talking about place, and I think really useful potentially for this kind of indexing and data discovery kind of use case. And then the last thing that we touched on was there's also a lot of work in schema.org around IoT data models. And they're not always the most compatible with the kind of O&M observation based data models. And there's probably a world where we actually need to have IoT kind of sensor things style observations and measurements, SOSA style, and schema.org or more kind of mass market profiles of the same data holdings coming out of our catalogs. And that's probably just something to ponder over a foamy beverage, but that was something worth noting. I think there's probably some worthwhile exercise to do there as a informatics person who works for an organization with a lot of monitoring data that could be viewed in all three lenses. I think it's something we probably need to work on. So that's my summary. And I think the common thread there is kind of schema.org profiles that would give some concrete guidance to data providers and would get us moving forward on building the crawlable kind of set of information that we all kind of want to put into our search tools. So. Did I miss anything? Is that good?
The only thing I would add, and happened sort of late, so may not have made it into your notes, was the connection with the semantics, and we briefly touched on the ontology stuff. And I think that when you're talking about sort of qualifying location in some way, and identifying that there might be a way to do that in such a way that sort of what we were talking about of isolating space from other qualifiers of that space for referencing an instrument, and whether there'd be a way to, I don't know, I'd love to have this conversation with you at some point about just what are those qualifiers, and can you actually make a list of those, or does it need to be free form? If you can make a list, then maybe you can make some kind of relationship choices there. Anyway.
Yeah, right. We have a lot of work to do on domain, for lack of better terminology, domain feature models, and getting them used more consistently for typing places and understanding what kinds of relationships places can have to other places. I think that's what you're talking about, right?
Yeah, because it looked like one of your efforts was to really be able to nail down the context, the whole context, which goes beyond just like where is this on the planet, to also include other things that are maybe more relative spatial kind of things, and I'm wondering if those are if you don't need to build a whole planet thing to accommodate that, you can attach, you can link, using linked data, say I'm interested in this location, but in this way, right? Or with this qualifier or something, and maybe being able to assign an ID to that combination would make it easier for your users, or maybe you just let them pick. If there's 3 things to pick from, there's 3 fields that together form something that's unique.
Yeah.
Something to think about.
Is this like an anatomy of features? Is that how we're understanding this? So I heard things like, dam is continuous with the water course, et cetera, right?
Yeah.
Is that
right? Yeah, essentially. So this would be a type scheme a class model for spatial things that gives you an ontology for what's allowable for a relation from one type of spatial thing to another.
So we have some of that in some of the ontologies we deal with in the semantic tech cluster, semantic tech community and harmonization cluster. Sure, I'll put an example in the chat for just a general building. There are stubs for dams, but it's not that specified. And a reference ontology wouldn't specify to that degree, but we have a lot of the ingredients that are probably needed. And also the relations.
That was essentially my saying we've got a lot of work to do in a lot of the work's been done in defining these things, but getting commonality of usage and kind of getting that canon in place so we can start to make inference about things we find in the wild is a ways off.
Sounds like here maybe we're just inviting you to fill it in somewhere where the tools are also going to get built for you.
Yeah, and getting these things published in a way that people can discover them is not always easy.
I mean, to some degree. Oh, sorry. Go ahead.
Sorry, Pim. It's Peter Fox. Hey, Dave. Is Steve Richard on the call on this session?
Yes, I am.
Sorry to
I
cut
am.
you out, but I'm sitting here thinking all that sort of new work that you guys all did on GeoSciML has to factor into this conversation, and it sort of always sat sometimes at the center and sometimes at the periphery, but you did a lot of work on features, didn't you? And all this work is really cool.
So the thing is I mean, that we defined various kinds of features, but with a very narrow focus on geologic features. So geologic units, structures, and the geologic time stuff came out of that as well. But I think, Dave, you're talking about something that's sort of a broader kind of ontology of geography kind of thing as well, right?
What I'm talking about includes GeoSciML.
Yeah.
That's one of the models that we're trying to get published. So actually, this is coming quite soon. Rob Atkinson is working on the OGC Def server to be able to publish JSON-LD contexts and turtle owl file kind of ontologies for the UML-based domain models that have been defined in OGC. So that includes GeoSciML, GWML2, high features. So these environmental domain class models will be published as ontologies that we can start to reference. So
that's another interesting topic for conversation.
For sure. No, and that's a parallel effort in Elfie Selfie, is we've been like, you know what, we need resolvable types so that we can start to actually reference these things in the wild and have something that works.
Right.
And yeah.
So Dave, just a tongue-in-cheek thing, you said there's a lot of work to do, and I think you've just identified, if you get Rob Atkinson and Nick Carr together, it'll be done tomorrow, seriously.
Well, Nick's working with a Geologic Survey of Queensland on a pretty extensive set of those kinds of classes.
Yeah.
It'll be done tomorrow, but there'll be a year of technical debt to fix. Sorry.
Well, Peter, another one is the minerals ontology, I think, that you've been working on with the Deep Carbon Observatory.
Yep, I think there's a lot of, I think that's, you and Anirudh have been talking about that. I think that's really close to sort of being a bit more prime for everyone to use. That would be really interesting, especially for the USGS folks.
Yeah, I'm looking forward to seeing that.
Yeah, this is an exciting time. This geoconnects.us work that we've kind of broken open here with Kyle's help has been really exciting to see unfold. And there's a few other things happening that we're positioned to do some things in the next little while. So I think we should let's pull this back. I guess, Ruth, are you seeing the parallels that I did?
Oh yeah, for sure. Yeah, to be exact, whatever your answers are for spatial, I think we need to, really be in sync because we have the same issues. I mean, for example, Amos, I know, has location names for features on maps, right? In various and sundry non-English languages, like Inuktitut and stuff like that. Yupik, you name it.
Yeah. So and actually, that's a really good point. One of the big selling points of this geoconnects.us is there's a sister system called geoconnects.ca. And we've got every intention of bringing them back together so that we have these kind of country-focused knowledge network systems that provide these reference features and the hopefully the long run the knowledge network that connects it all together. So that's another. It'd be fun to get Boyan and Eric to the table to work on this as well. So. Many of you know Boyan and Eric.
Well, we have
just a general sort of like a little challenge here. So, we have some of the ontology structures and conventions to solve a lot of these challenges and issues that you put forward. What's not fit for purpose with them in terms of your use case? So that is, if you want the anatomy and connectivity of things like dams to watercourses, et cetera, there's been this thing for like almost a decade now, generating content for that, reusing relations. Spatial relations are coming from anatomy, but they can be generalized to, planetary anatomy pretty quickly. What it lacks is, let's say, the breadth, but that can be driven from what you guys are finding, the structures that you're finding, et cetera. There are ways we can sort of semi-automate the creation of the semantic content and the IRIs and just leverage the systems that are already up there and interoperate with Suite and therefore then the GCMD if we figure out that bridge. So I'm curious as to what else is needed or what we can provide to help you along. It sounds like, that's what worries me. It just kind of sounds like you're gearing up to generate, just do this again somehow. Of course, that's fine. You guys run your thing, you run the system, but there's a lot of stuff that's been going on that could probably help you guys on.
There is, and we've got people speaking a lot of different languages here, so it's hard to nail the problem down in a way that's evocative. The piece we've been missing is driving commonality of usage to data providers' distribution of their data. And I think the only successful path is to get that done, but also insert the semantics into what gets implemented by data providers in their offerings. So in a lot of ways, it's not about the semantic technology. We all know that there's really good triple stores and knowledge graph implementations and a lot of smart and well-designed ontologies. It's really, from my perspective anyways, it's really a matter of getting the usage and simplifying things enough that people can do it consistently.
Right. So it's like if there's a really simple store integrated into some geospatial technology that people don't even have to think about that. They just like draw something around it and they say, this is that. That's really the user experience.
And in addition, you want people in that domain to have the confidence that whatever semantic mapping occurs, that they can actually trust it.
I think that's where the semantic harmonization cluster comes in, because that's what Ruth does with the global cryosphere watch, making sure that our ontology content matches what that international group defines from their glossaries, etc. So if there would be another semantic harmonization group to do this, at least for some test cases, then we could engineer that trust and also give control over that subgraph to share governance of that so that nobody changes it and messes up the ecosystem.
So Pierre, it's also this is from Chuck, just a quick comment on that. So there's a couple issues, right? So there's a sort of a tooling issue, I think. I think that there is also a slight semantic issue in that, what a lot of people are interested in is the findable part of FAIR, right, for discovery, right? And so that says schema.org, but schema.org has a different sort of level, quote unquote, of semantics than say something like ENVO, right? And so the harmonization has to occur also across these sort of different levels of semantic specification, so to speak, right? Not just in terms of terminology, right? So because you're somewhat limited in what you can say in schema.org, but then you can have a crosswalk that hops to something like ENVO, which can say an awful lot, and then provide the information to application developers that basically says, if your application is just trying to expose things for crawling, then you can do this. If your application actually wants to do, more deep things and be able to be smarter, then you can do this, right? And so I think it's wiring those things up also that we have to start thinking about.
Yeah, but I really take the point about the application development, because much of this stuff has to happen in the background. No user is going to then hop over to a Sparkle thing, if they're working in a GIS environment. So, but that would be a really cool challenge just to scope out, just to see how these things relate. So at least we know where this stuff is positioned and how we can help each other.
Yeah.
And who we need, to complete the thing.
One other thing I would offer, we need to wrap up, but one other thing I would offer here is, I came from a presentation this morning where we are using high features, a class model that can be expressed as an ontology, for a SQL schema, a class model for an object-oriented modeling framework, a resource model for web pages that may or may not be semantic, and it maps onto the concepts that environmental fluid mechanics engineers find to be evocative. And that combination, that's like, it's ultimately it's an expression of the knowledge, but it's also gotta be evocative and useful and add up conceptually in all those other kind of
right. Yeah, that's a really good point. And I think that's also what we're talking about in our visioning session, in the sense that should be preserved because the community knows how to use it and addresses those needs specifically. But that's where the people developing that's what we're trying to do with ENVO, Suite, and others. Those resources themselves should be interoperable. So if somebody wants to hop over from one to another for whatever reason, it's possible.
Yep.
So that might be the point we can focus on.
Yep, I agree. And that's a challenge. That's one of the big, that is the challenge. So cool. This has been fantastic. I think we walked away with some pretty good actionable stuff to collaborate on, largely in the science and schema.org space, but probably in a lot of other spaces. We've got a bunch of notes. Looks like this is the top of our time, right?
This is the top of your time. There's no pressure to get out of this room. The next session starts in 30 minutes.
I guess my question is, do we want
if we
had a report out from
have an opportunity for? We're on the same page, Ruth.
I figured. I kind of like to hear what C&D did. It could be really brief.
Yeah, where did they go?
I think Lewis left. Looks like, I don't know if Blake or somebody else from the C group could report out, and then Lewis is still here, and Ted did leave, so he's over in a hangout.
Okay, very quickly. Unsurprisingly, we kind of ran out of time, and that I think that was to be expected, but it's okay. We covered authoring vocabularies and ontology mappings, what Git publication workflows look like, serving content for your domain name as opposed to one which is produced within core. An example of this is like suiteontology.net, and maybe soon to be some of the extensions being provided through geoschemas.org or maybe scienceonschema.org, whatever. The fact that core can accommodate that. Browsing and querying core via the web app, core interaction via representational state transfer, REST, core interaction via a client-side development kit, such as Python or Java or whatever. Really, feedback is, there's some interesting use cases, and I think in that session, quite rightly, we were geared up to present people with the tools and the guidance to onboarding into core, rather than something a bit further down. At one point it was getting a bit in the weeds, so we pulled it back out and kept on charging forward. So I think it's maybe quite a nice contrast to some of the other conversation, because it's technology track rather than whatever. It's quite a nice contrast to some of the other content which was going on here. We've got some feedback. I am kind of adding what I can remember into the document for our session minutes. So overall, you know, we want to have more time, but I think it was still valuable. There's a whole slide deck there now that people can have a look at if they want to go back and get the resources, and really that's the most important part as well. I want to just mention to people as well, for some of the stuff that we're talking about, there's a big world of structured data out there, and you know, the way in which core has been designed is for flexibility to accommodate a lot of these different manifestations of the way in which you want to maybe author and publish your data. We're pushing more stuff onto the YouTube channel, so we've got a couple of videos, tutorials essentially there, but we're pushing more on there. So when they are there, they just get announced into the Slack channel. That's about it, to be honest with you. Back over to you, David or Amber. I wasn't on mute, was I?
No, you weren't. You weren't. I was.
Right, okay.
I
I thought I was on mute the whole time.
Searching for my window.
I thought it was. I'm trying to search for mine. I thought it was on mute.
And Amber said her internet's getting really choppy, so she may or may not be present. No, that's cool. And the YouTube resources are going to be really useful.
Yeah,
that's great. And then perhaps Dave V could do an update for Group D.
Yeah, sure. I can do just a quick overview of what we talked about. Let's see, there we go. So yeah, we just talked about some different tools that are available now and emerging and so forth that different groups are working with. And so I gave a little perspective from the scienceonschema.org group on some of the tooling that's going on there, and the shackle rules that are being developed and for the guidelines and so forth. For those that are interested, there's going to be a scienceonschema.org session at 4 o'clock today, where we'll go into more detail about that stuff. There's a bit of discussion about you know, how much adoption of JSON and JSON LD there is across the different groups, and a lot of I guess a lot of hand-wringing about you know, XML versus JSON, relative efficiencies and inefficiencies of different technologies associated there. I'm just kind of trying to remember what we talked through in the session real quick. Yeah, we just made a very brief list of some of the popular tools that are used for working with JSON and JSON LD, and some discussion about, you know, the various advantages and disadvantages of using JSON LD in particular versus JSON, and JSON LD versus XML. If anybody else that was in the group wants to add some comments, feel free to.
Was there any content there that should get transferred into schema.org for discoverability? That's kind of one thing I would close out of here. if folks can visit the tab in our Kigo chat around 3 takeaways and help fill those out, that'd be fantastic. I think the organizers will do that at some point either way. But and then the other thing is there's an awful lot of notes generated from all these breakouts, and like what you were just talking about there, Dave, would be, was there some conversation that should get ported to a findable resource?
Okay, I'll take a look at the notes and see what we can transfer over. But I think it was really just an information sharing session about what tools people are using.
Yeah. Cool. Well, this has been super educational, and I've been thrilled to be able to interact with everybody here. It's been such a big and active and great group. I think we have 20 minutes till the next session starts up. So we should let everybody go. But like I said, if you have a chance to follow up in the three takeaways section, that'd be great. Otherwise, yeah, thanks for coming along and taking part. And thanks I don't see Aaron anymore. Honored to have Aaron get this session kicked off for us. So, all right. Have a good one, everybody. We'll see you.